Picture an object so impossibly dense that a single teaspoon of its matter weighs as much as an entire mountain range. This cosmic structure hides the massive weight of a roaring sun within a sphere no larger than our own planet Earth. It is a world where gravity has won its final crushing battle, condensing every individual atom into a state of absolute and crystalline perfection. Imagine invisible lines of force so powerful they could snap a metal needle from across the vast, lonely reaches of the galaxy. These magnetic monsters spin in the silent dark, casting rhythmic lighthouse beams of X-ray light that slice through the interstellar medium with mechanical precision. They are the ultimate unseen guardians of the stellar graveyard, ruling their local space with a magnetic ferocity that defies all terrestrial logic. Surprisingly, the very heart of this ghost star is not composed of flickering fire, but of a single, moon-sized diamond. This hidden treasure rings like a massive cosmic bell, vibrating with the deep, melodic echoes of a life that spanned untold billions of years. It is a silent, permanent monument to the power of time and the breathtaking beauty of a universe that turns stellar death into a singular, untouchable gemstone. If we were to look closer, we would see a star that has long since run out of fuel, yet refuses to surrender to the encroaching chill. It maintains its shape through the stubbornness of subatomic particles, standing as a quantum shield against the weight of the entire universe. This is the ultimate fade, a journey from a blinding blue birth to an invisible ironclad peace. This quiet room is your sanctuary from the overwhelming scales and the crushing pressures of the deep cosmos. You're safe here, resting in a pocket of profound and undisturbed calm as the stories of the stars begin to unfold around your awareness. These wonders are yours to inherit as you sleep, drifting peacefully through the majestic history of a darkening sky. Allow the weight of your tired limbs to sink fully into the soft, reliable support of your bed, releasing every last bit of the day's lingering tension. Your mind is free to wander through the crystalline landscapes and the quantum paradoxes of the far future, while your physical form remains perfectly secure and warm. You're anchored in this moment of total, effortless relaxation, prepared to witness the emergence of a phantom. The journey begins at the very edge of the freezing void, where the cooling remnants of a once mighty sun prepare to reveal their final, glowing secrets. Deep within the dying embers of a sun-like star, a glowing dense core is slowly revealed to the immense freezing void of space. Deep within the dying embers of a sun-like star, a glowing dense core is slowly revealed to the immense freezing void of space. For billions of years, this central furnace was completely hidden beneath churning layers of roaring plasma and violent nuclear fusion. It miraculously sustained an entire solar system with its boundless energy, keeping the encroaching darkness at bay through sheer gravitational and atomic willpower. Now that furious engine has finally sputtered to a halt, exhausted of the hydrogen and helium fuel that originally gave it life. The crushing weight of the star's own outer layers can no longer be held back by outward radiation pressure. As the star exhales its final cosmic breaths, the magnificent architecture of its exterior simply drifts away into the interstellar winds. What remains behind is a striking naked heart of pure, blistering energy. This newly exposed core is no longer a burning star in the traditional sense, but a super-compressed sphere of incredibly hot matter. Stripped of its vast atmospheric blankets, the brilliant ember stands absolutely alone against the silent backdrop of the galaxy. This cosmic structure emerges only after the parent star has violently expelled its outer atmospheres into a breathtaking, colourful planetary nebula. As the aging giant undergoes its death throes, intense thermal pulses ripple outward from deep within its collapsing interior. These massive shockwaves push the star's outer gaseous envelopes entirely off their original gravitational moorings. Picture expanding spheres of superheated gas, blooming like a cosmic flower across trillions of miles of empty space. Ribbons of magenta, teal, and gold cascade through the darkness, painting a temporary but magnificent portrait of stellar death. This expelled material carries away vital elements forged over aeons, seeding the surrounding galaxy with the necessary building blocks of future worlds. At the absolute centre of this chaotic, expanding storm sits the newly minted white dwarf, acting as the quiet anchor to the brilliant display. The ghost of the former star illuminates the surrounding nebula with fierce, high-energy light. It is a stunning visual paradox where the very end of a star's active life creates the most beautiful masterpiece of its entire existence. Surprisingly, the universe creates these intense remnants entirely from stars that lack the sheer mass required to forge heavy iron. True stellar behemoths possess enough gravitational might to crush carbon and oxygen into increasingly heavier elements until their cores turn entirely to solid iron. Such massive titans inevitably detonate in spectacular supernova, tearing themselves to absolute shreds and leaving behind only bizarre black holes or ultra-dense neutron stars. The progenitors of white dwarfs, however, represent the quieter, more modest majority of the galactic stellar population. They spend their immensely long, stable lives peacefully fusing lighter elements, never reaching the catastrophic internal pressures needed to unlock the final, fatal stages of nuclear alchemy. When their internal fires eventually die down, they simply lack the physical weight to collapse all the way into utter oblivion. If we were to look closer at the absolute centre of this expanding nebula, we would find an object roughly the size of Earth, but holding the massive weight of an entire star. The sheer scale of this physical compression defies ordinary human comprehension and challenges the fundamental limits of matter. A sphere that once stretched millions of miles across has been violently squeezed down into a planetary footprint. Consider the crushing reality of taking the entire mass of our Sun and packing it tightly inside the relatively tiny volume of our home planet. Every single atom is pushed so closely together that the empty space normally existing within them is completely eradicated. The resulting density is so profound that a simple sugar cube-sized chunk of this material would weigh practically as much as a small mountain. Despite its diminutive planet-like dimensions, this object completely commands the local gravitational environment, just as it did when it was a full-size star. Any orbiting planets that survive the outer layer's expulsion will continue circling this tiny speck exactly as they circled the original giant. It is a perfect illusion of scale, hiding a terrifying amount of mass behind a deceivingly small, glowing silhouette. The intense heat of its recent formation causes the newly born white dwarf to glow with a brilliant, searing ultraviolet blue light. Having just been stripped of its insulating outer layers, the exposed core vents the accumulated trapped heat of 1 billion years directly into the freezing void. Surface temperatures routinely soar past 100,000 degrees Celsius, dwarfing the relatively cool surface of our own active Sun. Because of this extreme thermal energy, the vast majority of the light radiating from the newborn star is completely invisible to the fragile human eye. It blasts its surroundings with a relentless torrent of high-energy ultraviolet radiation and incredibly potent X-rays. If a spacecraft were to somehow fly near this tiny object, its sensors would be instantly blinded by the sheer ferocity of the invisible glare. Surrounding gases are dramatically illuminated by the sheer volume of high-energy radiation pouring relentlessly from the exposed naked core. The discarded outer layers of the parent star, now drifting lazily away into interstellar space, act as an enormous, multicoloured canvas for the dwarf's radiant light. Atoms within the expanding nebula are violently excited by the bombardment of ultraviolet photons, causing them to glow with intense, specific colours. Vibrant neon greens highlight the presence of doubly ionised oxygen, while deep, blood-red hues betray the signature of shifting hydrogen clouds. This celestial fluorescence transforms the quiet cosmic graveyard into a dazzling, glowing beacon that can be seen from thousands of light-years away. The white dwarf essentially powers its own spectacular light show, painting the surrounding cosmos with the scattered remains of its own body. As the radiation sweeps outward, it also acts like a gentle cosmic wind, slowly accelerating the nebular gas away from the central star. The shape of the glowing clouds is sculpted by this steady pressure, forming intricate hourglasses, perfect rings, or delicate butterfly wings in the dark. Without the blistering light of the hidden central ember, these beautiful structures would remain completely invisible and unknown to the galaxy. As millennia slowly march onward, the expanding nebula inevitably fades into the interstellar medium, leaving the white dwarf completely isolated in the dark. The colourful ribbons of gas drift further and further from the central heat source, losing the radiant energy required to maintain their brilliant fluorescent glow. The cosmic masterpiece gradually dissolves, returning its enriched elements back to the vast, swirling galactic ocean. This profound isolation marks the true beginning of the white dwarf's unimaginably long journey through deep time. Without a sprawling atmosphere or an illuminating cloud of gas to announce its presence, the star becomes incredibly difficult to spot against the backdrop of larger living suns. It simply drifts through the dark, an orphaned diamond slowly losing its heat to the unforgiving vacuum of space. It is truly fascinating to realise that almost 97% of all stars in our sprawling Milky Way galaxy will eventually share this exact stellar fate. When we gaze up at the glittering night sky, nearly every single point of light we can see is destined to become a quiet, shrinking ember. The magnificent supergiant stars that detonate in fiery glory are actually exceptionally rare anomalies in the grand cosmic census. The vast, silent majority of the universe is built upon the backs of these modest, hard-working stars that simply burn until they quietly fade. Our own yellow sun, along with the Alpha Centauri system and the brilliant Sirius, are all steadily ticking down toward this precise transformation. They're all temporary, roaring furnaces waiting patiently to shed their skins and join the hidden legions of the dark. This overwhelming statistic reveals that white dwarfs are not bizarre cosmic freaks, but rather the standard ultimate destination for stellar matter. The galaxy is already littered with billions of these ancient unseen ghosts, quietly drifting through the spiral arms completely unnoticed. They are the true enduring cosmic majority, representing the final lasting monuments to the fleeting era of starlight. Witnessing this incredible birth means watching a star transition permanently and irreversibly from a state of active fusion to one of passive cooling. For its entire prior existence, the star waged a dynamic, roaring battle against the crushing force of its own gravity by fusing atoms in its core. Every second of its life was defined by the violent, energetic creation of new elements and the outward push of immense radiation pressure. Now that grand internal furnace is extinguished forever, leaving no mechanism to generate fresh heat or hold back the weight of time. The star has effectively died, crossing a critical threshold from a living, breathing cosmic engine into a static, slowly dying ember. There will be no more roaring flares, no more nuclear alchemy, and no more explosive attempts to balance the scales of physics. All that remains is the slow, agonizing bleed of residual heat into the absolute zero of the surrounding universe. This passive cooling process will dictate the rest of the object's existence, spanning a timeline so vast it makes the age of the current universe look like a brief spark. It is a transition from an era of glorious, energetic chaos into a permanent, unyielding era of quiet decay. Because it no longer churns or fuses new material, the remaining core acts essentially as a perfect cosmic fossil, holding the pristine chemical history of its parent star. Locked firmly within its unimaginably dense crystalline interior is the exact elemental recipe of the star at the very moment of its ultimate death. The accumulated carbon, oxygen and trace metals forged over billions of years are frozen permanently in place, trapped completely by the crushing, inescapable quantum pressure. By carefully analysing the incredibly faint light emitted by these cooling dead stars, modern astronomers can accurately read these fossilised records from directly across the galaxy. They can brilliantly reconstruct the entire life story of a star that perished long before the Earth was even fully formed, simply by examining the chemical makeup of its frozen heart. It allows us to physically peer backward through deep time, understanding the rich galactic environment and the raw elemental materials that existed in the universe's distant past. These silent, shrinking phantoms serve as the ultimate cosmic archives, preserving the grand legacy of the Milky Way in solitary spheres of ultra-dense diamond. They hold the secrets of forgotten worlds and ancient suns, guarding them fiercely against the ravages of time and the expanding dark. Long after the last living star has burned out, these brilliant fossils will remain, echoing the chemical triumphs of a vibrant starlit universe. Echoing the chemical triumphs of a vibrant starlit universe requires a profound release of trapped ancient energy. When the active furnace finally shuts down, the newly consolidated surface does not immediately turn cold, but instead burns with an agonizingly intense residual fever. Freshly formed remnants radiate at temperatures vastly exceeding 100,000 degrees, a level of thermal aggression that defines their earliest era. This staggering surface heat is not generated by fresh nuclear reactions, but is simply the unshielded warmth of the former core laid bare. The incredibly dense interior acts as a nearly perfect thermal conductor, ferrying deep internal heat outward to the extraordinarily thin atmospheric boundary. As a result, the entire surface becomes a blistering, uniform shell of unimaginable kinetic fury. To comprehend this environment is to imagine a realm where the very concept of matter is pushed to its absolute thermal limit. Particles at the surface vibrate and collide with such extreme violence that any complex molecular structures would be instantly pulverized. It is a harsh, uncompromising frontier where the legacy of the parent star screams its final, scorching testimony into the cosmic dark. Because of this extreme thermal energy, the vast majority of the light radiating from the newborn object is completely invisible to human eyes. The laws of quantum physics dictate that as a body grows hotter, the peak of its emitted light shifts relentlessly towards shorter, more energetic wavelengths. Therefore, the searing blue glow is actually only a tiny leaking fraction of a much deadlier storm of extreme ultraviolet and X-ray radiation. If our visual perception was suddenly tuned to see high-energy X-rays, these tiny remnants would outshine almost everything else in the galactic neighbourhood. They are brilliant, blinding beacons of invisible light, slicing through the interstellar medium with photons carrying immense destructive power. This invisible torrent acts as an aggressive, ionizing wind that sterilizes any stray comets or floating debris drifting too close to the surface. Such intense radiance is a stark reminder that the cosmos operates on scales entirely detached from standard biological perception. We are completely blind to the true overwhelming majesty of these objects without the aid of specialized orbiting observatories. The brightest, most violent songs of this celestial symphony are sung in a register we simply cannot perceive without mechanical assistance. As millennia slowly pass into millions of years, the dominant colour of the dead star inexorably shifts from blinding blue to stark, pure white. The finite reservoir of internal heat is continuously radiating away into the freezing expanse, forcing a gradual but unstoppable drop in surface temperature. With this cooling, the peak of the electromagnetic emission slides slowly back across the spectrum, eventually centering directly within the visible light range. This is the precise era that gives the celestial body its famous, enduring name, as it shines with an unblemished alabaster glow. It is a stunning, perfect white, blending every colour of the visible rainbow into a single piercing beam of crystalline purity. The aggressive, sterilizing high-energy radiation has finally subsided, leaving behind a pristine luminous pearl suspended in the absolute darkness of the void. As you rest here, allowing the quiet rhythm of your own breathing to deepen, imagine that steady, pure white light washing over you. Feel the tension leaving your muscles, replaced by the profound, undisturbed calm of an entity that has finally found its permanent equilibrium. Let your body sink entirely into a state of total relaxation, perfectly anchored and completely safe in your current resting space. Notice how the light from this dense remnant lacks the chaotic, unpredictable flickering so common to a standard, active burning sun. Living stars are boiling cauldrons of twisting magnetic fields, churning convection zones, and massive solar flares that constantly alter their overall brightness. They are essentially violent, roaring oceans of plasma, relentlessly shaking and trembling under the immense strain of active nuclear fusion. In stark contrast, a cooling, degenerate star shines with a perfectly steady, eerie calm that feels almost unnatural in a turbulent cosmos. Stripped of violent convection currents and internal explosions, the glowing surface is incredibly smooth and remarkably placid. The emission of photons is a highly regulated, even process, pouring out into space without a single ripple, stutter, or explosive fluctuation. This unblinking stare makes the dead star appear more like an artificial, perfectly polished gemstone than a natural evolving celestial body. It is a monument to absolute stillness, a quiet watcher casting an unwavering gaze across the vast, twisting spiral arms of the galaxy. The pristine silence of its light is a profound testament to the end of all internal conflict and the triumph of permanent stability. Even after quietly shedding its heat into the freezing void for over 1 billion years, the remnant surface remains incredibly hotter than our own sun. One might expect such a tiny object to freeze quickly, much like a hot ember removed from a roaring campfire. However, the sheer density of the collapsed star means it holds an absolutely astronomical reserve of thermal energy locked within its core. Furthermore, the extremely thin atmosphere blanketing the surface acts like a remarkably efficient opaque thermal blanket stubbornly trapping the internal heat. Only a strictly rationed amount of energy is permitted to escape into space at any given moment, creating an agonizingly slow cooling process. It is a celestial masterclass in energy conservation, rationing a single, finite burst of heat across a timeline that stretches into billions of years. Therefore, long after the surrounding galaxy has dramatically evolved, the ember continues to burn with an intense, fierce heat. A theoretical visitor to this ancient system would still be instantly incinerated if they approached the smooth, glowing surface. It is a stubborn, enduring warmth that utterly defies the crushing, absolute zero temperature of the surrounding cosmic ocean. Yellow and golden orange hues eventually take over the stellar profile as the surface temperature finally drops below 10,000 degrees. The stark, piercing white slowly softens into a warmer, more inviting glow, resembling the gentle light of a perfectly carved piece of amber. This transition marks the passage into the star's middle age, an era defined by a deep, beautiful chromatic shift toward lower energies. As the heat dissipates, the physical chemistry of the incredibly thin atmosphere begins to subtly alter the quality of the escaping light. Atoms that once existed in a state of violent ionized plasma begin to recombine, absorbing entirely different frequencies of radiation. This changes the optical signature, acting like a gentle atmospheric filter that bathes the surrounding system in a rich, golden twilight. This incredibly predictable, gradual color change acts as a highly precise cosmic thermometer for astronomers observing the sky from our home world. Because these objects possess no active energy generation, their rate of cooling is governed by straightforward, undeniable laws of thermodynamics. By carefully measuring the exact shade and temperature of the escaping light, scientists can precisely determine exactly how long the star has been dead. When observing a massive, ancient globular cluster containing hundreds of thousands of bodies, finding the coolest, faintest remnants provides a critical temporal anchor. It is the celestial equivalent of carbon dating, allowing researchers to calculate the true chronological age of the entire stellar neighbourhood. If an observer locates a dwarf glowing with a specific shade of pale yellow, they know with absolute certainty how many aeons have passed. This elegant property transforms these dead stars into the most reliable, enduring clocks in the entire observable universe. They tick onward not with the swinging of a pendulum, but with the steady, irreversible shift from brilliant blue to golden yellow. Through them, we are granted the profound ability to measure the true depths of deep time and map out the aging process of existence itself. By the time the stellar remnant dims enough to glow a dull, deep red, the universe around it has aged by untold, staggering billions of years. This crimson hue represents the twilight of the star's visible existence, the very lowest energy state that can still be perceived by optical instruments. It is the exact colour of a dying coal buried deep within the ashes, fiercely clutching the very last fragments of its ancient warmth. These ruby-coloured spheres are among the absolute oldest objects currently existing anywhere in the sprawling, majestic cosmos. To look upon one is to look back at an entity that was forged during the earliest chaotic epochs of galactic formation. They have silently witnessed the birth and death of countless other stars, the slow merger of galaxies, and the restless shifting of the cosmic web. The dull red light is a melancholy, hauntingly beautiful final stanza in the grand, sweeping symphony of the star's luminous life. It casts long, dark shadows across any surviving frozen planets that might still be locked in its unyielding gravitational grip. The brilliant, roaring days of the past are nothing more than ancient history, replaced by a quiet, brooding vigil in the eternal dark. This persistent dimming never truly stops, continuing inexorably until the star emits only the faintest trace of an invisible infrared glow. As the surface temperature plummets below a few thousand degrees, the light slips entirely out of the visible spectrum, plunging the surrounding space into darkness. To biological eyes, the star has completely vanished, swallowed whole by the overwhelming silent blackness of the freezing void. Yet, if one could perceive heat itself, they would see a faint ghostly sphere stubbornly radiating its final whispers of warmth. Deep within the core, the immense carbon and oxygen lattice continues to crystallize, releasing tiny, latent amounts of energy to slow the final chill. It is a desperate, microscopic defense against the ultimate victory of absolute zero, a lingering phantom of a once mighty sun. Let every muscle in your body go completely slack, embracing the profound, silent darkness of this perfectly peaceful state. You are drifting in a realm of absolute quiet, wrapped in a comfortable, soothing blanket of deep rest and tranquility. The endless march of cosmic time passes by harmlessly as you remain perfectly centered, entirely calm and completely undisturbed. Only the absolute most sensitive modern telescopes can detect these ancient, fading infrared embers against the freezing, deep cosmic backdrop. Searching for them is an incredibly difficult endeavour, equivalent to trying to spot a single glowing firefly against the glare of a massive distant searchlight. Their thermal signatures are so astonishingly weak that they are constantly drowned out by the bright, active universe endlessly swirling around them. To find these ultimate survivors, observatories must be launched into the freezing vacuum of space, far away from any obscuring planetary atmospheres. These delicate instruments must be supercooled themselves, allowing their incredibly sensitive mirrors to catch the absolute faintest photons of heat drifting across the galaxy. It requires a monumental feat of engineering and patience to capture the dying breath of a star that perished before our world was even born. Before our home planet was even a swirl of dust, the dying breath of these ancient bodies established a terrifying, inescapable physical dominion over their local space. Gravity on the surface of a collapsed stellar core pulls with a ferocity hundreds of thousands of times greater than the gentle force anchoring us to our world. It is a fundamental warping of space-time so severe that it redefines the very rules of physical interaction in its vicinity. To understand this crushing weight, one must picture the invisible fabric of the cosmos being dragged sharply downward into a deep, steep-walled gravitational well. The sheer density of the remnant concentrates an enormous amount of mass into a staggeringly small volume, creating a localized inward pull that borders on the catastrophic. Nothing within its immediate realm can resist the relentless, demanding tug toward the absolute center of the sphere. This overwhelming force dictates every single physical property of the dead star, from its perfectly spherical shape to the bizarre behavior of the space immediately surrounding it. It is a silent, invisible tyrant ruling over a frozen, isolated system where the standard laws of buoyancy and mass are stretched to their breaking points. The remnant exists in a state of eternal self-siege, constantly trying to crush itself out of existence. Consider the material itself, a bizarre state of ultra-compacted substance that defies all terrestrial logic or geological comparison. If an intrepid cosmic miner were to somehow scoop up a single teaspoon of matter from deep within this dense star, they would be holding a terrifying paradox. That tiny, unassuming spoonful of stellar material would weigh several tons if it were miraculously transported down to our planet's surface. Such extreme density occurs because the fundamental building blocks of matter have been stripped of all their internal empty space. The immense inward pressure has forced the very nuclei of the atoms into an impossibly tight embrace, creating a substance far denser than solid lead or uranium. It is a material forged not by chemical bonds, but by the raw brute force triumph of gravity over the repulsive forces of atomic structure. Holding that small, impossibly heavy scoop would be akin to supporting the weight of a massive, fully loaded industrial vehicle in the palm of your hand. It is a sobering reminder that the matter making up our bodies and our world is overwhelmingly composed of empty space. In the heart of this gravitational anomaly, that comforting emptiness has been completely, ruthlessly evicted. If a theoretical explorer in a highly advanced vessel could miraculously survive the descent and attempt to stand on this bizarre surface, their journey would meet an instant, spectacular end. The downward acceleration is so profoundly absolute that a biological body would not simply fall, but would be immediately and violently smeared across the stellar crust. They would be instantaneously flattened into an unfathomably thin layer, measuring less than a single atom thick. Flesh, bone, and advanced composite metals would all suffer the exact same fate, losing their three-dimensional structure in a fraction of a microsecond. The body would be physically integrated into the surface of the star, its constituent atoms shattered and rearranged to conform to the overwhelming, crushing flatland. It is an environment completely and utterly hostile to any form of complex structured geometry. Feel the gentle, supportive surface beneath your own resting body, noting how it cradles your weight without requiring any effort on your part. You exist in a delicate, perfect balance of forces, entirely safe from the violent extremes governing these distant, ultra-dense spheres. Sink deeper into that profound safety, letting the staggering realities of the deep cosmos merely wash over your imagination, while your physical form remains totally secure. Because of this absolute intolerance for vertical geometry, towering mountain ranges or deep, plunging canyons cannot possibly exist in this environment. Any geological bump or surface irregularity taller than a few centimeters is instantly crushed perfectly flat by the extreme, relentless downward pull. The landscape is a masterclass in aggressive leveling, presenting a flawlessly smooth, featureless horizon stretching out in every direction. If a massive asteroid were to impact the crust, it would not excavate a deep, bowl-shaped crater like the ones scarring our lunar surface. Instead, the incredible mass of the impactor would simply melt and spread out uniformly, forced to immediately conform to the perfect, unyielding curvature of the star. The crust behaves almost like an incredibly stiff, dense liquid, immediately sealing any wounds and erasing any vertical imperfections. This results in what is mathematically one of the most perfectly smooth, spherical objects in the entire known universe. There are no valleys to cast long shadows, no ridges to break the glowing horizon, and absolutely no terrain for any hypothetical visitor to traverse. It is a landscape defined entirely by its uncompromising uniformity, ruled by a force that strictly forbids any defiance of the horizontal plane. Escaping this uncompromising gravitational grip requires generating an incomprehensible amount of outward kinetic energy to break the invisible tethers. To simply leave the surface and avoid being pulled immediately back down, an object must travel outward at speeds reaching thousands of kilometers every single second. This required velocity is a significant fraction of the speed of light itself, presenting a nearly insurmountable barrier to conventional physics. Launching a standard chemical rocket from this perfectly smooth crust would be a completely futile, almost comical endeavour. The explosive thrust generated by burning fuel would be instantly overwhelmed by the titanic downward pull, pinning the vessel permanently to the ground. Only a propulsion system utilising antimatter or advanced, theoretical space-time manipulation could even dream of climbing out of such a profoundly steep gravity well. This intense escape requirement acts as an absolute cosmic quarantine, ensuring that whatever material falls onto the dead star remains trapped there for the rest of eternity. It is a one-way street in the grand energetic economy of the galaxy, a final resting place for errant gas and drifting dust. The remnant hoards its gathered mass with an iron grip, refusing to surrender even a single atom back to the void. The atmosphere blanketing this impossibly dense star is remarkably different from the sprawling, towering clouds of gas surrounding a living sun. Due to the staggering downward pressure, the entire gaseous envelope is forcefully compressed into a layer so incredibly thin it sometimes measures only a few dozen meters deep. It is a bizarre, two-dimensional ocean of gas tightly hugging the smooth, glowing crust of the remnant. If you were to stand on the surface, the absolute edge of space would not be miles above your head, but mere footsteps away in the vertical direction. This heavily squashed atmosphere still manages to govern the thermal radiation of the entire star, acting as a highly efficient opaque lid on the blazing interior. Despite its microscopic depth, it possesses an immense optical thickness, completely obscuring the crystalline lattice burning below. Picture this tightly wound shell of gas violently vibrating under the twin extremes of intense internal heat and crushing external gravity. It is a highly stressed, razor-thin boundary layer mediating the relationship between a dying stellar core and the freezing, empty vacuum of the cosmos. This shallow, heavy fog is the only face the dead star ever shows to the outside universe. Within this razor-thin atmospheric boundary, a remarkably efficient sorting process takes place, driven entirely by the overwhelming weight of the environment. Heavy elements like carbon, oxygen, or iron sink instantly down to the solid crust, pulled aggressively inward by their greater atomic mass. They are violently dragged out of the gaseous layer in a matter of days or weeks, disappearing completely from the surface spectrum. Allow your own thoughts to become as light and uncomplicated as that pristine layer of pure hydrogen, floating effortlessly above the heavier burdens of the day. Let any complex worries or dense anxieties sink away, dropping out of your immediate awareness until only a calm, peaceful clarity remains. You're suspended in a state of pure, simple relaxation, completely unburdened by the heavy gravity of daily stress. Astonishingly, even the fundamental particles of illumination are not immune to the relentless, demanding tug of this celestial tyrant. Light itself struggles desperately against this immense pull, losing significant amounts of energy just trying to climb away from the blindingly bright surface. As the photons fight to escape the deep gravitational well, their wavelengths are forcefully stretched out, shifting their colour toward the redder end of the spectrum. This phenomenon means the light arriving at our distant telescopes is fundamentally exhausted by its journey out of the dead star's domain. It is as if the glow is physically tired, having paid a massive toll in kinetic energy simply to break free and travel across the void. The colour we observe is not the true raw colour of the glowing surface, but a shifted, modified version that has survived a harrowing escape. Observing this tired, stretched light provides a direct visual measurement of the sheer, invisible strength of the star's gravitational field. It is a stunning realization that gravity does not merely pull on heavy rocks and gas clouds, but aggressively reaches out to drag down the very essence of light. The star forces the universe's fastest messenger to struggle, profoundly altering the messages it carries into the dark. This specific phenomenon of tired, shifting light served as a crucial, historical cornerstone in our understanding of modern theoretical physics. The undeniable observation of this gravitational redshift provided one of the key foundational proofs for Albert Einstein's revolutionary theory of general relativity. By capturing the stretched glow of a dense companion star, early 20th century astronomers confirmed that mass actively warps the fabric of space and time. Before this critical observation, the idea that gravity could act upon massless photons was a highly contentious, purely mathematical concept debated on chalkboards. The glowing, ultra-dense remnant provided a perfect natural laboratory, offering an extreme environment that simply could not be replicated on our homeworld. It boldly demonstrated that gravity is not just a simple attractive force, but a profound curvature in the fundamental geometry of the cosmos. The silent dead star therefore became an invaluable teacher, unlocking the profound secrets of how the grand clockwork of the universe truly operates. Its crushing weight illuminated the hidden mechanisms of reality, forever altering the trajectory of human scientific endeavour. We owe our modern comprehension of massive singularities, expanding space-time, and the cosmic web to the exhausted light struggling away from these heavy spheres. The spatial warping around the remnant is so severe that it creates an incredibly hazardous zone for any wandering celestial body. Objects approaching too closely are violently torn apart by overwhelming tidal forces long before they ever touch the flawlessly smooth surface. The gravitational pull on the near side of an incoming asteroid is vastly stronger than the pull on its far side, creating an immense, fatal stretching effect. This sheer differential in gravity acts like a set of invisible cosmic claws, mercilessly ripping solid rock and metal into chaotic spinning clouds of shrapnel. A solid planet foolish enough to stray into this lethal perimeter would find its crust shattering, its mantle unzipping, and its core spilling out into the void. The dense star does not merely pull objects in, it systematically dismantles them, rendering them down into manageable raw materials. These resulting pulverized fragments are then smoothly incorporated into the swirling, doomed accretion disks that slowly spiral down onto the pristine hydrogen atmosphere. It is a dramatic, brutal demonstration of absolute physical dominance, where the dead core violently enforces its supremacy over the local void. Even in death, the star commands a terrifying authority, punishing any entity that dares to cross the invisible threshold of its immense, crushing weight. This crushing weight, while an instrument of destruction for anything external, acts as a profound architect within the stellar interior. Deep inside the star, where the density reaches its most extreme concentrations, the immense pressure physically forces carbon and oxygen atoms into a rigid, structured lattice. This is not the chaotic, fluid dance of a typical sun, but a transition into a state of matter that is fundamentally solid and unyielding. The atoms, once free to jostle in a sea of degenerate electrons, find themselves locked into a precise geometric arrangement that defies their thermal desire to move. It is a microscopic surrender to the macroscopic power of gravity, a reorganization of reality into a grid of perfect symmetry. This internal scaffolding provides the star with a new kind of structural integrity, a resilience born from the very pressure that threatens to collapse it. As the star sheds its final whispers of heat into the void, this lattice grows increasingly more defined and pervasive. It represents the first step in a transformation that will turn a ball of cooling plasma into something far more permanent. This invisible, crystalline skeleton now supports the massive weight of the star, creating a foundation that will endure for as long as the universe exists. This remarkable process of crystallization begins at the absolute center of the dense core and slowly works its way outward over billions of years. As the interior temperatures drop to a critical threshold, the central atoms are the first to succumb to the geometric order of the lattice. This is not a sudden freeze, but a patient, creeping wave of solidification that gradually consumes the stellar heart. Each layer of the star must wait its turn, shedding enough thermal energy to allow the local pressure to finally win the battle for structure. It is a journey of transition that spans ages, moving atom by atom from the center toward the shallow, glowing surface. This slow-motion freezing creates a stratified interior, where a solid, crystalline heart is surrounded by a diminishing shell of super-dense fluid. The boundary between the solid and the fluid is a realm of intense physical change, where the very phase of matter is rewritten. It is a frontier that moves with a majestic geological pace, far removed from the rapid timescales of living stars. This creeping order ensures that the star's transformation is thorough, deliberate, and entirely unstoppable as it moves toward its final, frozen state. If we were to look closer at the sheer scale of this transformation, we could picture the interior gradually transforming into a single, gigantic diamond suspended forever in the vacuum of space. The carbon atoms, compressed far beyond anything possible in a terrestrial laboratory, align themselves into a structure identical to the gems found in the Earth's crust. However, this is a gemstone on a planetary scale, a single crystal of carbon stretching across thousands of miles of depth. This cosmic diamond is not clear and faceted like a piece of jewellery, but is instead a dark, ultra-dense matrix that would be virtually indestructible. Its value and its beauty are purely mathematical, a result of the perfect alignment of trillions upon trillions of atoms under the weight of a sun. It is a treasure forged in the heart of death, a glittering prize that no human hand will ever touch. Within this massive crystal, the very concept of a star is redefined from a burning ball of gas to a solid, permanent relic. The diamond interior becomes the star's new identity, a crystalline legacy that remains long after its light has faded into infrared whispers. It is the ultimate manifestation of the universe's ability to turn the remnants of destruction into something of profound, structured elegance. Surprisingly, the transition from a fluid state to this crystalline lattice does not happen without a significant energetic signature. The latent heat released during this freezing process actually causes the white dwarf to temporarily pause its relentless, multi-billion-year cooling. As the atoms settle into their final positions within the solid grid, they surrender their kinetic energy, creating a sudden, internal surge of warmth. This thermal feedback acts as a hidden reservoir, a final gift of energy from the star's own physical restructuring. For a vast span of cosmic time, the star's surface temperature remains strangely static, defying the expected trajectory of a cooling ember. It is as if the star is holding its breath, refusing to surrender to the encroaching chill, while its heart turns to stone. As you rest in the quiet stillness of your own environment, notice the steady, reliable rhythm of your heart, echoing the deep pulses of energy within the cosmos. Feel the warmth of your own body as a constant, gentle presence that anchors you to the here and now. You're perfectly balanced in this moment, held by the same fundamental laws of thermodynamics that govern the slow, rhythmic cooling of the stars. Because of this significant thermal pause, many crystallized white dwarfs appear observationally much younger than their true chronological age. Astronomers looking at these stars see a surface that is still glowing with a heat that should have vanished millions of years prior. It creates a deceptive appearance of youth, a stellar mask that hides the true antiquity of the object beneath a layer of recycled warmth. This discrepancy forces scientists to develop complex mathematical models to account for the stolen time provided by the crystallization process. Without understanding this phase change, the history of the galaxy's oldest stars would be fundamentally miscalculated. The diamond heart essentially acts as a fountain of youth, artificially extending the era during which the star can be seen across the vast distances of space. This optical illusion is a reminder that in the deep cosmos, things are rarely as they first appear to the casual observer. The star is a master of endurance, using its own internal solidification to buy more time against the encroaching darkness. It is a quiet, brilliant strategy for survival, allowing these ancient ghosts to linger in the light far longer than physics would otherwise permit. Deep within the solid, crystalline interior, sound waves travelling through the lattice ring out like a massive, continuous cosmic bell. Unlike the muffled, chaotic noises of a gas giant, the rigid structure of the diamond dwarf allows vibrations to propagate with incredible clarity and speed. These internal tremors are the heartbeat of the crystal, a low-frequency song that hums through the entire mass of the star. If we could translate these vibrations into a frequency human ears could perceive, the sound would be a deep, resonant tone that never wavers. It is the music of a solid world, a harmonic resonance born from the perfect alignment of its constituent atoms. The star literally rings with the energy of its own existence, a solitary instrument playing for an empty audience in the void. These vibrations are not random, but are carefully dictated by the size, density, and temperature of the crystalline core. They carry information about the star's deepest secrets, travelling from the centre to the surface where they leave tiny, detectable ripples in the light. This constant ringing is the star's only voice, a rhythmic vibration that tells the story of its internal transformation to anyone capable of listening. This scientific field, known as astroseismology, allows astronomers to study these subtle vibrations to accurately map out the hidden diamond core. By observing the tiny fluctuations in the star's brightness over time, researchers can essentially perform an ultrasound on the stellar body. They look for the specific patterns created by the sound waves as they bounce off the boundaries of the internal crystal lattice. This technique has revealed that many white dwarfs are far more solid than previously suspected, with diamond hearts that occupy a vast majority of their volume. It allows us to see through the thin, glowing atmosphere and the liquid shell to the rigid structure beneath. We're no longer guessing about the interior. We're measuring its dimensions and its purity through the very tremors it produces. Allow your mind to become as still and receptive as the specialized telescopes that capture these distant rhythmic signals. Let your awareness expand into a state of quiet observation, where even the smallest shifts in your own environment are noticed with peaceful detachment. You're a calm observer of your own internal landscape, perfectly attuned to the subtle, relaxing rhythms of your resting form. A specific celestial body known as BPM 37093 has become famous in the scientific community for being a confirmed diamond dwarf. Located in the constellation of Centaurus, this object is roughly the exact physical size of our moon but possesses the staggering mass of a sun. Scientists have affectionately nicknamed it Lucy, a tribute to the famous song celebrating a sky filled with glittering treasures. Observations of Lucy's pulsations have confirmed that at least 90% of its interior has already transitioned into a solid, crystalline state. It is a world-sized gemstone drifting 40 light-years away, a silent testament to the incredible pressures that define the end of a star's life. It stands as a tangible example of the theoretical landscapes we've discussed, a real place where the ground is made of compressed diamond. Finding an object like BPM 37093 provides the empirical proof needed to ground our understanding of stellar evolution in reality. It is a beacon of clarity in the dark, showing us exactly what our own sun might look like in the distant, unimaginable future. Lucy is a glimpse into the ultimate fate of most stars, a crystalline ghost that proves the universe is a master of turning death into beauty. The sheer financial value of such a gem is purely theoretical, as the intense gravity would destroy any mining equipment instantly. While a diamond the size of a moon would be worth more than the total wealth of human history, the physical reality of the environment makes it a forbidden treasure. Any drill, probe, or vessel attempting to touch the surface would be crushed into a layer of dust before it could even begin its harvest. The very forces that created the diamond are the same forces that protect it from any external interference. It is a treasure guarded by the laws of physics themselves, held in a gravitational vault that no technology can hope to breach. Human greed is rendered meaningless in the face of such cosmic authority, as the star refuses to surrender even a single carat of its crystalline heart. This serves as a humbling reminder that some of the universe's most magnificent creations are meant only to be observed from a distance. The diamond dwarf is a masterpiece of structure that demands respect and awe rather than exploitation or possession. It exists in its own realm, a perfect and untouchable jewel that belongs entirely to the silence of the expanding cosmos. Eventually, the entire stellar body will freeze completely solid, locking its atomic structure in place for all eternity. This final solidification marks the end of the star's journey as a dynamic entity, reaching a state of absolute physical permanence. Every single atom, from the deepest core to the thinnest boundary, will be integrated into the unyielding crystalline lattice. This state of total crystallization represents a victory of order over the entropy that dominates the rest of the universe. While galaxies collide and black holes evaporate, these frozen gems will drift through the void as silent, unchanging monuments to the stars they once were. They are the ultimate survivors, their internal structures protected by the very density that makes them so formidable. In this final, frozen configuration, the white dwarf becomes a permanent part of the cosmic landscape, a jewel that neither grows nor fades. It is a profound realization that the most energetic fires in the universe ultimately result in the most stable, enduring structures ever conceived. The journey from a roaring sun to an eternal diamond is finally complete, leaving behind a legacy of absolute silence and crystalline perfection. Crystalline perfection is the ultimate state of order, but beneath that serene, unmoving facade, a silent and invisible power often reigns supreme within the local cosmos. Certain highly magnetized white dwarfs possess fields that pull with a ferocity millions of times stronger than the magnetic grip of the Earth. While our planet's magnetic shield is a gentle protective whisper that guides the migration of birds and preserves our atmosphere, the fields surrounding these stellar remnants are a deafening, invisible roar of force. They are not merely stronger in degree, but represent a fundamental shift in the intensity of physical interaction. This invisible aura extends far into the surrounding vacuum, warping the paths of light and matter alike as it radiates from the star. It is a remnant of the star's original magnetism, concentrated billions of times over as the stellar core collapsed into its final compact form. Like a massive spring that has been coiled to its absolute limit, the magnetic field is packed into a tiny volume of space, creating a density of force that is virtually unparalleled in the universe. This magnetic dominion defines the star's interaction with the galaxy, turning a simple cooling ember into a formidable anchor of invisible influence. As you lie there, feel the gentle, reliable pull of the Earth's gravity and magnetism holding you safely in place. Your body is supported by forces so subtle and constant that you rarely even notice their presence. Allow yourself to sink further into this comfort, knowing that you are cradled by a world of soft, predictable fields that ask nothing of you but to simply exist and breathe. These invisible forces act as an inescapable cage for any matter that dares to loiter in the star's immediate vicinity, trapping charged particles and funneling them with terrifying precision toward the magnetic poles. Electrons and ions are snatched from the surrounding space and forced to spiral along twisting, invisible lines of magnetic tension. They have no choice but to follow the predetermined paths dictated by the star's immense polarity, cascading downward in a relentless focused stream toward the stellar surface. This process creates a constant invisible rain of high-speed particles that bombards the poles with the energy of 1 billion lightning strikes. Surprisingly, when this atmospheric matter moves along the twisting lines and impacts the star's surface, it creates massive, dark, storm-like spots that contrast sharply against the star's smooth face. These regions are not storms of wind or rain as we understand them, but areas where the magnetic pressure is so intense that it suppresses the normal flow of heat from the interior. Because the magnetic fields are so rigid, they prevent the superheated plasma from circulating freely, causing the surface in those specific areas to cool down significantly. They appear as shadowy, unmoving islands on a sea of white-hot light, marking the exact points where the invisible lines of force pierce through the stellar crust. These magnetic spots can be thousands of miles wide, yet they remain perfectly still, locked into place by the star's unyielding internal lattice. They provide a striking visual map of the star's internal magnetic architecture, revealing the complex, twisting nature of the fields that lie hidden beneath the surface. To an observer, the star looks like a mottled, glowing orb, its pristine white surface scarred by the invisible power that grips its core. This contrast between the radiant heat and the dark magnetic islands is a beautiful, silent testimony to the ongoing struggle between thermal energy and magnetic force. It creates a landscape of high contrast beauty, where the dark spots act as windows into the star's deepest, most powerful secrets. Radiation beaming from these energized poles can sweep across the vast, lonely emptiness of the cosmos like a high-energy lighthouse beacon as the dead star spins on its axis. As the particle streams slam into the magnetic poles at near-light speeds, they ignite with a brilliant, focused glare that emits pulses of radio waves, visible light, and intense X-rays into the void. Because the magnetic axis is often tilted relative to the star's rotation, these beams of light are flung in wide circles, cutting through the darkness with mathematical regularity. To a distant observer, the star seems to flash with a rhythmic mechanical precision, announcing its presence to the galaxy through a series of timed, invisible signals. This lighthouse effect allows astronomers to detect these magnetic monsters even when they are too far away to be seen as a resolved disk. The steady, pulsing rhythm of the radiation serves as a cosmic signature, identifying the star as a highly magnetized, rapidly rotating remnant. It is a hauntingly beautiful image, a tiny, Earth-sized diamond spinning in the dark, casting two brilliant, invisible searchlights across trillions of miles of space. Each pulse carries information about the star's rotation rate, its magnetic strength, and its internal structure, bridging the gap between the distant observer and the alien world. As you rest here, let the image of that rhythmic, pulsing light soothe your mind into a deeper state of relaxation. Imagine the steady, predictable heartbeat of the universe, echoing the steady rhythm of your own heart. You're in perfect sync with the grand, quiet cycles of the cosmos, moving through time with a calm, effortless grace that requires no thought or action on your part. Scientists currently believe that these extreme, record-breaking magnetic fields might be born during the violent and chaotic orbital mergers between two separate white dwarfs. In many binary systems, two of these dense remnants will slowly spiral toward one another over billions of years, eventually colliding in a spectacular display of gravitational and thermal energy. When they touch, their individual magnetic fields are not simply added together, but are violently twisted and amplified by the shear forces of the collision. This creates a swirling, superheated dynamo of incredible complexity, where the rotational energy of the merger is converted into pure magnetic force. The resulting single star is a hybrid of their masses, possessing a magnetic signature that is vastly more powerful and complex than anything they could have produced as individuals. This theory explains why some white dwarfs are nearly non-magnetic, while others are monsters of force. The high-field stars are likely the survivors of these ancient titanic unions. The merger is a process of extreme rebirth, where the death of two stars creates a new, more formidable entity that carries the legacy of both progenitors. It is a testament to the fact that in the universe, even the most quiet and dead objects can interact to create something of unprecedented power. These magnetic giants are the heavyweight champions of the stellar graveyard, born from the most intimate and violent interactions possible in the dark. The rapid spinning of such a highly magnetic dwarf can act like a massive unipolar electrical generator, driving enormous continuous currents of electricity into the surrounding vacuum of space. The interaction between the star's rotation and its intense magnetic field creates a potential difference that can reach trillions of volts, turning the entire star into a planetary-scale battery. This immense electrical pressure accelerates electrons and ions to near-light speeds, launching them far out into the interstellar medium in powerful, focused jets. This process transforms what was once a quiet, cooling ember into a dynamic cosmic power plant, radiating energy that can influence the local environment for light years in every direction. These electrical currents are not confined to the star's surface, but extend into a sprawling, invisible magnetosphere that interacts with the thin gas of deep space. As the star spins, its magnetic field lines sweep through the surrounding medium like giant invisible oars, stirring up the local plasma and creating ripples of electromagnetic energy. The star literally powers the space around it, creating a realm of high-energy activity that defies the expected silence of a stellar remnant. This electrical output is another way the star manages to shed its remaining energy, trading its rotational momentum for a spectacular display of electrical and magnetic influence. It is a machine of pure physics, operating with a level of efficiency that human engineers can only dream of achieving. If we were to look closer at the atoms caught in this intense, unrelenting magnetism, we would see them become severely distorted, stretching out physically into thin, needle-like shapes. Under normal conditions, the internal electrical forces between the nucleus and the electrons hold an atom in a roughly spherical cloud. However, in the presence of these magnetic monsters, the magnetic pressure is so great that it overcomes these internal bonds, forcing the electron clouds into elongated, highly stressed configurations aligned with the field lines. This is a state of matter that cannot exist anywhere else in nature, where the very building blocks of reality are warped by an invisible, irresistible hand. This distortion changes the entire chemical behavior of the matter on the star's surface, as the atoms can no longer bond in traditional ways. Chemistry itself is rewritten in these extreme environments, leading to the formation of bizarre, one-dimensional molecules that would instantly evaporate in a weaker magnetic field. The matter becomes as strange as the gravity that holds it down, a collection of needle-thin particles standing on end like the fur of a frightened animal. It is a profound realization that even the smallest units of our universe are not fixed, but can be bent and reshaped by the overwhelming power of a dying star. Notice the sensation of your own body, feeling the fluid, natural way your cells and atoms interact in this gentle environment. Your physical form is a masterpiece of soft, spherical balance, free from the stresses and distortions of the deep cosmos. Let this realization of your own physical harmony deepen your sense of peace, allowing you to appreciate the quiet, effortless stability of the world around you. Light emitted from these strangely distorted atoms behaves bizarrely, splitting into multiple distinct wavelengths as it struggles to escape the magnetic trap. Under normal conditions, an atom releases light at specific, well-defined frequencies, creating a clear and predictable spectrum that acts as a chemical fingerprint. However, when the atom is stretched into a needle-like shape by intense magnetism, its energy levels are shifted and fragmented. This causes the emitted light to break apart into several separate beams, each carrying a slightly different colour and polarisation than the original. Instead of a single, clear line in the spectrum, the light appears to a distant telescope as a complex, fragmented fan of colours, each piece carrying a different signature of the magnetic tension. This fragmentation creates a visual chaos that challenges our traditional understanding of how starlight should look when it reaches our eyes. The light is literally bruised by the magnetic field, transformed into a multi-layered signal that tells the story of the star's invisible power. This splitting is not just a visual oddity, it is a fundamental alteration of the way energy moves through space, a direct consequence of the star's ability to manipulate the fabric of reality itself. It turns the star's glow into a coded message, waiting to be deciphered by those with the tools to see it. This specific splitting of light, known formally to physics as the Zeeman effect, is exactly how astronomers measure the hidden magnetic strength of these stars from thousands of light years away. By carefully analysing the distance between the split spectral lines, researchers can calculate the exact intensity of the invisible magnetic field with remarkable precision. It is a stunning feat of scientific deduction, allowing us to see the magnetic monster even when its lines of force are completely transparent to the naked eye. The light itself becomes a detailed map of the star's invisible power, carrying the evidence of its magnetic strength across the vast gulfs of interstellar space. Named after the physicist who first observed it in a laboratory, the Zeeman effect turns every magnetic white dwarf into a natural experiment in high-energy physics. We do not need to visit these stars to know they are there. We simply need to catch their light and pass it through a prism. The wider the gap between the split lines, the more powerful the magnetic field must be. This technique has revealed that some white dwarfs are essentially non-magnetic, while others are the most powerful magnetic entities in the galaxy. It is a bridge of light that connects our terrestrial laboratories to the most extreme environments in the universe, proving that the same laws of physics apply whether we are in a small room on Earth or at the edge of a dying star. Navigating a standard compass anywhere near this environment would result in the metal needle snapping off instantly from the sheer, overwhelming magnetic violence. On Earth, a compass needle gently aligns itself with the North Pole, providing a steady and reliable guide for travellers. However, near a magnetic white dwarf, the force is so localised and intense that the needle would be physically torn toward the star's magnetic centre before it could even begin to pivot on its axis. The mechanical stress would exceed the tensile strength of the metal, causing the needle to shatter or bend into a useless scrap of iron. It is a world where the familiar tools of navigation and physics are rendered completely useless, replaced by a landscape of invisible, twisting tension that dominates every cubic inch of space. Any electronic device would be instantly fried by the induced currents, and any metallic structure would be subjected to enormous physical forces. The magnetic field acts as a final, impenetrable wall, a barrier that protects the star's secrets from any form of mechanical intrusion. It is a place of pure, unadulterated power, where the invisible lines of force are more real and more dangerous than any solid mountain or churning sea. As you finish this leg of the journey, allow yourself to drift back into the complete safety of your own space. Feel the profound, silent peace of your environment, where the only force acting on you is the gentle, loving weight of your own relaxation. You're perfectly safe, perfectly still, and entirely free to simply be, letting the wonders of the magnetic monsters fade into a distant, beautiful memory of crystalline perfection. This state of crystalline perfection suggests a quiet end, yet the reality of the cosmos often involves a far more chaotic and interactive existence. While some remnants drift in solitary splendour, many white dwarfs do not exist entirely alone, locked instead in tight, fast orbits with living, normal companion stars. This cosmic partnership creates a gravitational bond that is both intimate and destructive, forcing the two stars into a frantic, dizzying dance across the void. The companion, Often a star, very much like our own sun, remains oblivious to the predatory nature of its compact partner as they whirl around a common centre of mass. Every revolution brings the two bodies into a tighter embrace, governed by the invisible tethers of gravity that refuse to let go. In these binary systems, the dead star is no longer a silent observer, but an active participant in a high-stakes orbital game. It exerts a disproportionate influence on its larger, living neighbour, tugging at its atmosphere with a tenacity that belies its small size. This relationship defines the destiny of both stars, ensuring that neither will ever know the simple, lonely cooling of a solitary phantom. If we were to look closer at the boundary where these two stars meet, the scene would reveal a violent transfer of power. If the companion star expands naturally into a red giant as it ages, the white dwarf's intense gravity will begin mercilessly siphoning away its outer atmospheric layers. The living star finds itself unable to hold onto its own gaseous skin, which is pulled away in long glowing streamers toward the smaller, denser object. This process, known as Roche lobe overflow, marks the beginning of a parasitic relationship that will span millions of years. The stolen material is not merely lost to the void, but is claimed as a fresh resource by the hungry white dwarf. A bridge of plasma forms between the two stars, a shimmering umbilical cord of hydrogen and helium that flows steadily toward the gravitational well of the remnant. It is a slow dismantling of a living sun, atom by atom, as the compact core asserts its dominance over its bloated neighbour. This transition from a stable binary into a cannibalistic system represents one of the most dynamic and transformative phases in the life cycle of stellar pairs. This stolen gas does not fall straight down onto the surface of the white dwarf, but instead spirals rapidly into a blistering superheated accretion disk. Because the stars are in constant motion, the falling material possesses immense angular momentum that prevents a direct collision. Instead, it enters a high-speed orbit, swirling around the dead star in a flat, glowing plate of matter that resembles a miniature incandescent galaxy. The innermost layers of this disk spin at a significant fraction of the speed of light, creating a vortex of unimaginable kinetic energy. Within this swirling maelstrom, atoms are crushed and accelerated until they glow with a ferocity that can outshine the stars themselves. The disk becomes a secondary source of light and heat, a brilliant ring of fire that hides the tiny white dwarf at its centre. This structure is a masterpiece of fluid dynamics, where the simple act of falling results in a complex structured landscape of radiation and force. It is the sensory heart of the cannibalistic system, a place of constant motion and blinding brightness that defines the local space. Friction violently generated within this swirling disk produces intense X-rays, signalling the ongoing theft of stellar material to the entire galaxy. As the gas particles collide and rub against one another in their frantic orbits, they release their gravitational energy as high-frequency radiation. This energetic glow is a siren song that allows astronomers to map the invisible currents of the disk and measure the rate at which the white dwarf is feeding. The X-rays slice through the darkness, penetrating vast clouds of interstellar dust to announce the presence of a cosmic cannibal at work. Surprisingly, the sheer volume of energy released by this friction can be greater than the nuclear output of a living star. The accretion disk acts as an efficient engine, converting gravitational potential into raw, radiating power with terrifying efficiency. It creates a localized environment of high-energy physics that would be impossible to replicate in any terrestrial laboratory. This radiant signature is the definitive proof of a binary system in crisis, a lighthouse of invisible light that reveals the violent mechanisms hidden within the quiet graveyard of stars. As you lie in your current space, take a moment to notice the absolute stillness of the air around you. Feel the weight of your limbs sinking into the support beneath you, contrasting with the high-energy chaos of the distant disk. Your own environment is a sanctuary of low energy and slow movements, allowing your mind to drift peacefully while the universe carries out its most energetic processes elsewhere. You're perfectly insulated from the friction of the stars, resting in a pocket of profound, undisturbed calm. As fresh hydrogen constantly piles up on the dwarf's surface, physical pressure builds to a critical, explosive thermonuclear threshold. The stolen gas is not simply absorbed. It is crushed against the unyielding, degenerate surface of the star by the immense gravitational pull. Because the white dwarf is so dense and hot, the bottom layer of this new hydrogen shell becomes incredibly compressed and superheated. It sits like a layer of high explosive fuel atop a white-hot anvil, waiting for the exact moment when the conditions reach a tipping point. A spectacular detonation ensues, blowing the gathered gas forcefully into space in a brilliant flash called a nova. When the temperature at the base of the hydrogen shell finally hits the ignition point, the entire layer undergoes runaway nuclear fusion almost instantaneously. This is not the controlled, steady burning found in a normal star, but a violent, explosive release of energy that consumes the entire shell in a matter of days. The resulting blast wave hurls the atmosphere outward at thousands of kilometers per second, creating a shell of glowing debris that expands into the void. To a distant observer, the star suddenly flares up, becoming thousands of times brighter than its usual state, and often becoming visible to the naked eye where nothing was seen before. This new star or nova illuminates the surrounding system with a blinding, temporary glare before slowly fading over several weeks. It is a catastrophic release of the energy stolen over the preceding centuries, a brief moment of reclamation where the white dwarf violently sheds its borrowed skin. The explosion is so powerful that it can be seen across the entire galaxy, a sudden exclamation point in the long, slow story of the star's decay. Remarkably, the white dwarf survives this massive surface explosion entirely intact and soon begins stealing gas all over again. Because the detonation occurs only in the thin layer of accumulated hydrogen on the surface, the dense, degenerate core of the star remains completely unaffected by the blast. The core's immense gravity and rigid structure are far too strong to be disrupted by a mere surface flare-up, no matter how violent it may appear. Once the smoke clears and the expanded shell of gas dissipates into the interstellar medium, the white dwarf is revealed once more as solid and unyielding as ever. The binary dance does not end with the explosion. The gravitational tethers remain as tight as they were before the nova. Almost immediately, the siphoning process resumes, and a new stream of gas begins to flow from the companion star into the accretion disk. The white dwarf is a persistent predator, untroubled by its own outbursts and ready to begin the long process of accumulation once more. This cycle of theft and explosion can continue for as long as the companion has material to give, making the nova a repeatable, cyclical event in the life of the system. Take another deep breath, letting the air move in and out of your lungs with an easy, natural rhythm. Feel the steady, reliable beat of your heart, a constant cycle of life that requires no effort and brings only comfort. You're anchored in a cycle of peace, far removed from the violent repetitions of the binary stars. Allow yourself to settle further into this predictable, soothing rhythm, finding total relaxation in the simple consistency of your own being. Sometimes, the companion star is fully consumed over millions of years, leaving the dwarf entirely alone with the wreckage of its feast. As the white dwarf repeatedly siphons away the outer layers, the companion star grows smaller and less massive, eventually losing its ability to sustain nuclear fusion. It may be reduced to a brown dwarf or even a cold planet-sized object, a hollowed-out shell of its former self. The once vibrant sun becomes a stellar corpse, its life essence having been completely drained by its compact, relentless partner. This final stage of evolution results in a lonely, quiet system where the primary star has essentially eaten its neighbour. The debris from the consumed companion may form a dusty ring, or a faint nebula around the white dwarf, acting as a grim reminder of the cannibalism that took place. The white dwarf itself may have gained significant mass from the encounter, altering its own evolutionary path and perhaps setting the stage for an even more dramatic future. It stands as a solitary victor in a long gravitational war of attrition, surrounded by the silent remnants of the star it once called a companion. These cyclical surface explosions can repeat exactly every few decades or centuries, constantly lighting up the historical night sky. Known as recurrent novae, these systems are so perfectly balanced in their mass transfer that they produce predictable rhythmic outbursts. Throughout human history, astronomers have recorded the sudden appearance of these stars, noting their positions and their temporary brilliance. Ancient records from across the globe often contain descriptions of these guest stars that appeared for a short time and then vanished back into the dark. Modern science has allowed us to connect these historical observations with specific binary systems, revealing the long-term patterns of their behaviour. We're now able to predict when certain stars will next undergo their periodic detonations, turning the chaos of the nova into a scheduled event. These recurring flashes are a testament to the stability of the white dwarf's core and the relentless nature of its gravity. They act as a cosmic metronome, ticking away the centuries through a series of brilliant explosive pulses that bridge the gap between ancient history and modern astrophysics. The violent interactive physics in these binary systems create some of the most morphologically complex and beautiful nebulae in the known universe. As the nova explosions and the steady winds from the accretion disk push material into space, they interact with the gas already present in the system. The orbital motion of the two stars carves out intricate shapes, such as spirals, bipolar lobes, and delicate rings that glow with the light of the central remnants. These structures are often highly symmetrical, reflecting the precision of the binary orbit and the intensity of the magnetic fields at play. The resulting clouds of gas are not just random piles of debris, but are sculpted works of art, illuminated by the high-energy radiation of the white dwarf. They serve as a temporary monument to the turbulent relationship between the two stars, a visual record of the theft and the explosions that defined their partnership. Eventually, these beautiful clouds will fade and dissipate, leaving only the silent, cooling stars behind. For a few thousand years, however, they stand as the most vibrant and complex landscapes in the galaxy, a final, glowing testament to the power of companions and cannibals in the deep dark. While these glowing testaments eventually dissipate into the deep dark, a far more absolute boundary governs the silent, cooling stars left behind. This rigid, mathematical weight limit is known famously to physics as the Chandrasekhar limit, a threshold that no white dwarf can cross without facing total annihilation. It represents the maximum amount of mass that the internal pressure of degenerate electrons can possibly support against the relentless, inward crush of gravity. For a star made of such dense, compacted matter, this ceiling is fixed at approximately 1.4 times the mass of our Sun. Named after the visionary who first mapped its properties, the limit acts as a cosmic guardrail, preventing these dead stars from growing indefinitely. Every white dwarf in the galaxy is subject to this fundamental law, which balances the strange rules of the subatomic world against the massive scale of stellar evolution. It is a quiet, invisible number that holds the power of life and death over billions of stars. As long as a star remains below this precise value, it can drift peacefully for trillions of years. However, the moment this numerical barrier is challenged, the stability of the star evaporates. It is a transition from a stable, cooling fossil into a volatile engine of destruction. This limit ensures that the universe maintains a strict order, even in the chaotic aftermath of a star's death. This cosmic structure becomes increasingly unstable if it acts as a greedy predator, constantly feeding on the atmospheric layers of a nearby companion star. As the white dwarf siphons off fresh hydrogen and helium, its own mass steadily climbs toward that fatal, mathematical cliff. Each new streamer of stolen gas that spirals down onto the surface adds a small but measurable amount of weight to the compact core. While the star may appear unchanged from the outside, its internal pressures are mounting toward a point of no return. By the time the final handful of stolen gas falls into the gravitational well, the fate of the star is sealed. It has transitioned from a stable remnant into a gravitational bomb primed for an ultimate catastrophic detonation. The greedy nature of its relationship with its companion star has finally provided the exact amount of fuel needed for its own erasure. Surprisingly, the universe enforces a sudden and absolute penalty once the density threshold of the Chandrasekhar limit is finally breached. The internal degenerate electrons, which have successfully held back the weight of the star for billions of years, can no longer support the crushing external load. In a terrifying instant, the quantum force that provides the star's structural integrity simply fails, leading to a sudden and complete physical collapse. The star, which was once the size of the Earth, begins to shrink inward at a significant fraction of the speed of light. As you rest here, feel the light, rhythmic pressure of your own breathing as a gentle reminder of the stability of your own physical world. Notice how the floor or chair supports you with a constant, unwavering reliability that requires no thought from you. Your body is safely anchored in a realm where forces are balanced and predictable, allowing you to sink deeper into a state of profound, secure relaxation. While the star collapses, the atoms are jammed together with such violence that they lose their individual identities. This inward rush creates a state of extreme heat and pressure that is virtually unparalleled in the natural world. The collapse is the final act of a star that has lost its balance, falling into a void of its own making. It is a momentary surrender to the absolute power of gravity before the final, explosive response. Deep within the suffocating pressure of the star's collapsing centre, a catastrophic shift occurs within a microscopic fraction of a second. As the carbon and oxygen atoms are slammed together by the inward rush of mass, runaway carbon fusion ignites violently throughout the entire interior. This is not the steady, regulated burning of a living sun, but a simultaneous detonation that encompasses the entire volume of the star. The energy released is so vast that it creates a shockwave that travels outward through the dense stellar matter. This ignition happens so rapidly that the star does not have time to expand or dissipate the heat in a controlled manner. Instead, the entire mass of the white dwarf is turned into a single, massive thermonuclear bomb. Every atom of carbon is consumed in an instant, releasing a torrent of energy that challenges the fundamental limits of the material world. It is the most efficient and total release of energy possible for a stellar body, turning matter into pure radiation. The flash of this internal fire is the beginning of the end for the compact remnant. It marks the moment when the star ceases to be a physical object and becomes a source of blinding cosmic light. This internal ignition is the ultimate trigger, setting the stage for a display of power that will be seen across the vast gulfs of space. This total destruction is a unique characteristic of the Type 1a event, representing a complete conversion of a stellar body into an expanding cloud of radioactive debris. The massive energy of the carbon fusion provides more than enough force to overcome the star's own gravitational binding energy. It is a clean erasure, a final act that leaves the local space completely empty of its original anchor. The star has literally burned itself out of existence in a single, magnificent gesture. The heavy elements forged in the heart of this explosion, such as iron and nickel, are seeded into the surrounding galaxy. They will eventually become the raw materials for new generations of stars and planets, but the original white dwarf is gone forever. It is a profound transition from a permanent, crystalline fossil into a scattered cloud of cosmic dust. The resulting explosion is designated a Type 1a supernova, a phenomenon so powerful that it shines briefly much brighter than the combined light of an entire galaxy. For a few short weeks, this single point of light can outshine hundreds of billions of suns, acting as a brilliant beacon in the deep dark of the universe. The energy released is so intense that it can be detected across billions of light years, providing a window into the most distant reaches of space. It is the sensory peak of the star's journey, a blinding flash of ultimate catastrophic detonation. As you rest in the quiet stillness of your room, let your shoulders drop and feel the tension melting away from your neck and back. You're a peaceful observer of these distant wonders, safely removed from the blinding glare of the cosmic fires. Allow your mind to drift on the waves of this magnificent light, feeling completely calm and undisturbed as the universe reveals its greatest secrets to you. This blinding light is not just a display of power, but a vital signal for those who study the stars. It carries the signature of the white dwarf's unique composition and the specific physics of its final moments. The light of a Type 1 supernova is a pure and unblemished record of the total obliteration of a stellar world. It is the ultimate lighthouse, illuminating the structure of the entire cosmos with its brief, intense flare. Notice how this specific variety of stellar death possesses a remarkable and predictable consistency that sets it apart from all other cosmic events. Because these specific explosions always occur at the exact same mass threshold of 1.4 solar masses, they erupt with a uniform, predictable peak brightness. Every Type 1a supernova in the universe is essentially an identical twin, detonating with the same amount of fuel and releasing the same amount of energy. This uniformity allows them to act as standard candles, providing a reliable baseline for measuring the depth of space. This consistency is a gift to our understanding of the large-scale structure of the galaxy and beyond. By mapping these uniform flashes, we can build a three-dimensional model of the expanding universe with unprecedented accuracy. The white dwarf's final act of self-destruction becomes a beacon of clarity in a universe that is often difficult to measure. Astronomers utilize these remarkably consistent explosions as essential yardsticks to measure the accelerating expansion of the entire universe. By comparing the known brightness of these standard candles to their observed faintness, researchers can calculate the precise distance to galaxies billions of light-years away. This mapping process revealed a shocking truth that fundamentally altered our understanding of the cosmic timeline. The universe is not just expanding, but is doing so at an ever-increasing rate. A discovery that earned a Nobel Prize and challenged everything we thought we knew about gravity. Without the uniform light of the overloaded white dwarf, this discovery might have remained hidden in the shadows of the deep cosmos for centuries. These dead stars provide the necessary data points to track the history of the universe's growth over billions of years. They are the mile markers on the road to infinity, revealing the secret motions of the galaxies as they drift further and further apart. The explosion of a single tiny star provides the key to unlocking the fate of the entire cosmos. This measurement process connects the smallest, most dense objects in the sky to the largest scales of space and time. It is a bridge between the subatomic world of degenerate electrons and the grand evolution of the universe itself. The white dwarf's ultimate sacrifice provides the light we need to see the true shape of our reality. Our foundational understanding of the mysterious force known as dark energy relies almost entirely on witnessing the precise, final death throes of these overloaded white dwarfs. By measuring how the expansion of the universe has changed over time, scientists have deduced the existence of an invisible energy that acts as a repulsive force against gravity. This dark energy appears to permeate all of space, pushing the galaxies away from each other with increasing ferocity. The predictable light of the Type 1a supernova is the primary evidence that confirms this invisible, cosmic ocean exists. Embrace the silence of your room and feel the gentle weight of your hands resting peacefully by your side. You're a part of this vast, expanding universe, yet you are perfectly safe and still within your own pocket of existence. Let the concept of dark energy drift through your mind like a soft, quiet breeze, adding to your sense of deep, effortless relaxation. You're resting in a universe that is full of wonder and hidden depth, yet you remain perfectly calm and secure. Without the white dwarf's explosive signal, we would have no way to detect the influence of this mysterious force on the cosmic scale. the star's erasure becomes a window into the most profound and puzzling aspect of modern physics. It is a beautiful irony that the destruction of a small dead star reveals the secret engine that drives the entire universe toward its ultimate destination. This total erasure stands in stark contrast to the birth of the phantom we witnessed in the earlier stages of our journey. While many stars leave behind a cooling fossil to tell their story, the white dwarf that crosses the Chandrasekhar limit chooses a different, more dramatic finale. It transforms its entire being into a signal that can be seen across the cosmos, trading its permanence for a moment of ultimate galaxy-shaking brilliance. It is a final act of transformation that defines the limits of what matter can endure. The space where the star once sat becomes a quiet void, filled only with the fading echoes of a blinding, catastrophic light. Eventually, the heavy elements released in the blast will find their way into new nebulae, perhaps forming the heart of a new sun or the rocky crust of a distant world. The star is gone, but its impact on the structure and history of the universe is permanent and profound. This profound impact is most tragically felt in the immediate vicinity of the dying sun, where the very worlds it once nurtured are systematically reclaimed. When a star mirroring our own celestial neighbour eventually exhausts its core hydrogen, it undergoes a radical and violent physical inflation, swelling outward into a bloated crimson behemoth. This distended red giant aggressively expands its reach across millions of miles, moving with a slow but relentless hunger that eventually swallows the innermost orbiting planets in a roaring sea of cooling plasma. They are not merely touched by the heat, but are completely engulfed, dragged into the churning opaque layers where their crusts are vaporized and their atmospheres are stripped away in a matter of hours. The orbital friction against the dense stellar gas causes these doomed worlds to spiral inward toward the searing core, where they are ultimately dissolved and digested by the same fires that once gave them life. It is a total and pitiless destruction, an erasure of ancient landscapes and the quiet histories of alien life that never had the chance to escape the terminal expansion of their sun. The star, in its frantic attempt to survive its own inevitable cooling, consumes the very children it spent billions of years sustaining with its light. This expansion represents a final, irreversible breach of the cosmic contract between a sun and its satellite worlds. It is a haunting beginning to the formation of a graveyard, where the living system is reduced to a single cooling phantom. Surprisingly, the surviving outer planets, those giant worlds positioned safely in the frozen reaches of the system, are subsequently thrown into highly chaotic orbits as the star loses mass. During the red giant phase, the star sheds nearly half of its total weight through powerful rhythmic winds that blast away its outer gaseous layers into the interstellar void like a massive continuous gale. This massive reduction in central gravity fundamentally unbalances the delicate clockwork of the entire planetary system, causing the once stable paths of the surviving giants to drift and warp in the sudden gravitational vacuum. Without a steady anchor to hold them in place, these massive gas and ice worlds begin to migrate, tugged by the changing gravitational landscape and the nudges of their neighbouring giants. The neat circular orbits established over billions of years are replaced by wildly eccentric, overlapping paths that bring these massive worlds into dangerous proximity with one another. These planetary encounters result in violent gravitational slingshots, tossing some worlds entirely out into the dark of the galaxy, while others are pushed inward toward the central remnant. The transition from a living star to a white dwarf is accompanied by this period of absolute celestial instability, a frantic rearranging of what remains of the solar neighbourhood into a scattered, unpredictable graveyard. The orderly system is replaced by a landscape of displaced wanderers and debris, each world fighting for a new position in a broken system. Occasionally, a surviving asteroid or a fragmented rocky planet is knocked violently too close to the dead star's steep and unforgiving gravitational well. As the larger gas giants settle into their new, eccentric configurations, they act as cosmic billiards players, nudging smaller icy bodies and rocky remnants with the sheer weight of their immense gravitational wake. A single unlucky encounter can send a mountain-sized object hurtling away from its safe, distant haven and directly toward the tiny glowing ember that now sits at the system's silent center. This stray traveller, which may have spent eons in the quiet cold of the outer reaches, finds itself accelerating toward a point of light that is deceptively small but possesses the mass of a sun. The journey inward is a one-way trip through a field of increasing gravitational tension that warps the very space and time around the incoming object. Because the white dwarf is so compact, its gravity increases with terrifying speed as the distance closes, leaving the wandering body no room for maneuver or escape from the approaching singularity. It is a silent, lethal trap waiting in the center of the orbital ruins, ready to claim whatever pieces of the old world are delivered to its doorstep by the chaos of the migration. This inward journey is the prelude to a physical dismantling that is as beautiful as it is horrific to contemplate from the safety of the dark. As you contemplate the immense scales of these distant destructions, notice the absolute comfort and stillness of your own physical form. Feel the gentle, rhythmic rise and fall of your chest as you breathe, a small and vital cycle that continues effortlessly in your quiet sanctuary. You're perfectly supported and safe, existing in a moment of peace while your mind explores the turbulent edges of the cosmos. Tidal forces physically rip these wandering rocky worlds to shreds long before they can ever make physical contact with the star's smooth, glowing surface. As the doomed object crosses the invisible boundary known as the Roche limit, the gravitational pull on its near side becomes significantly stronger than the pull on its far side. This immense differential force acts like a set of invisible giant hands, grabbing the world and pulling it in opposite directions simultaneously with a strength that defies all structural logic. The internal bonds of rock, iron and ice are simply not strong enough to resist this stretching, and the planet begins to crack and unzip along its equator in a silent, violent process of disintegration. The world is systematically dismantled into smaller and smaller pieces, a process of planetary shredding that occurs with a cold, mathematical precision in the vacuum of space. Within a few orbits, what was once a solid, complex world has been transformed into a beautiful but deeply tragic ring of pulverized debris circling the phantom star. This ring of grit and shrapnel circles the white dwarf like a shimmering translucent halo, composed of the shattered remains of mountains, valleys, and ancient crust. It is a stunning visual epitaph, a necklace of dust forged from the violent death of a satellite that strayed too close to the heart of the void. Deep within this shimmering halo, the gritty planetary dust rains continuously down onto the otherwise pure and pristine atmosphere of the cooling white dwarf. The smaller fragments and microscopic particles within the ring lose their orbital energy through constant collisions and radiation pressure, causing them to spiral slowly toward the stellar surface. This is not a gentle mist, but a relentless, gritty downpour of silicate grains, metallic shards, and pulverized minerals that were once part of a planetary mantle and core. The intense gravity of the remnant accelerates this falling grit to incredible speeds, ensuring that every grain of dust impacts the surface with significant kinetic energy. As this debris enters the thin, heavy atmosphere, it is superheated and vaporized, turning the solid remains of a world into a glowing metallic gas. We can visualize the surface of the white dwarf as a smooth, white-hot anvil constantly being pelted by the pulverized ash of shattered moons and dead asteroids. This ongoing rain of grit represents the final stage of planetary consumption, where the physical remains of the system are finally incorporated into the star's own dense body. It is a slow and persistent burial of the system's past within the glowing light of the star's long and lonely present. By analysing the optical spectrum of the star, astronomers on our distant world can directly detect the chemical signatures of these shredded dead planets. Every element has a unique way of absorbing and emitting light, leaving behind a specific set of dark lines across the rainbow of the star's cooling glow. Under normal conditions, a white dwarf should show only the simple, clean signatures of hydrogen or helium, as its extreme gravity should have pulled all heavier elements deep into its crystalline core. When we see the distinct marks of iron, magnesium, or calcium in the light, we are witnessing the chemical fingerprints of the planetary dust currently falling through the atmosphere. This polluted light acts as a telegram from a graveyard, carrying the specific details of what was destroyed millions of miles away in a language made of photons. It allows us to perform a celestial autopsy on worlds that no longer exist, identifying the raw materials that once made up their alien mountains and dusty plains. The star essentially acts as a giant spectrographic furnace, burning up the evidence of its cannibalism and broadcasting the resulting chemical data across the galaxy. This forensic astronomy provides a window into the composition of alien solar systems that would otherwise be completely lost to the march of time. While you journey through these chemical memories, allow the weight of your body to fully merge with the surface beneath you. Feel the profound stillness of your surroundings, a quiet and safe environment where you're free from any physical demand. You're a silent observer of the cosmic past, perfectly relaxed and grounded in a world that is still vibrant and alive. We can literally read the core composition of alien crusts and mantles by watching them burn up in the dwarf's intense and unforgiving atmosphere. Because different layers of a planet are made of different materials, the chemical signature of the falling dust changes as different parts of the pulverized world reach the star. We might first see a spike in light elements common to a planet's crust, followed by the heavier silicates of the mantle, and eventually the rich iron and nickel of the shattered core. It is a layer-by-layer reveal of a world's internal anatomy, providing a level of detail that we cannot even achieve for the living solid planets in our own system. This process provides the only way to directly measure the bulk composition of rocky worlds orbiting other suns, bypassing the need for impossible mining missions to distant systems. We are watching the guts of a planet being turned into light, a violent but informative process that bridges the gap between geology and stellar physics. The white dwarf becomes a medium through which we can understand the building blocks of the universe, revealing how common or rare the ingredients for worlds like ours truly are. It is a hauntingly beautiful scientific opportunity, born from the total and absolute destruction of a planetary legacy that spent billions of years forming. Traces of water, carbon, and rocky silicates suggest strongly that many of these destroyed worlds were remarkably similar to the Earth we call home. When astronomers find high concentrations of oxygen and hydrogen in the atmosphere of a polluted white dwarf, it serves as a smoking gun for the existence of ancient oceans and icy moons. These are the same ingredients that allowed life to flourish on our own world, proving that the recipe for a habitable planet is scattered widely across the deep dark of the galaxy. We are finding the remains of worlds that may have once possessed blue skies, crashing waves, and the potential for a long and complex biological history. Seeing these familiar chemical signatures in the graveyard of a star is a discovery that is both exhilarating and deeply poignant for the human spirit. It confirms that the universe is capable of creating Earth-like environments in many different systems, but it also shows that these environments are ultimately and inevitably temporary. This ongoing planetary pollution ruins the otherwise perfectly pure and simple hydrogen or helium atmosphere of the dense dead star. For a white dwarf, purity is a state of physical equilibrium where the heaviest elements have been successfully sequestered far beneath the visible surface by the pull of gravity. The arrival of planetary grit is a disruption of this order, a staining of the star's pristine light with the complex debris of a shattered and dismantled system. If we were to look closer at our own future, it is a highly sobering reminder that our own solar system will very likely end as a dusty ring around a fading white dwarf. In several billion years, our sun will undergo the same expansion, engulfing Mercury and Venus, and likely stripping the Earth of its atmosphere and all of its vibrant life. Even if our homeworld survives the initial red giant phase, it will be left orbiting a tiny, dense remnant in a chaotic and unstable gravitational landscape. The most probable finale for the rock we stand upon is to be nudged into the white dwarf's well and torn into a shimmering halo of planetary grit. One day, a distant observer in another corner of the galaxy might point a telescope toward our fading sun and see the unmistakable signatures of iron, oxygen, and silicates in its light. They will read the story of our planet in the way it burns up, noting the chemical traces of the oceans and crust that once defined our home. Our entire history, from the first spark of life to the greatest human achievements, will be reduced to a few dark lines in a rainbow of cooling light. This realization ties our local destiny to the grand, repeating cycles of the cosmos, making us a part of the permanent and profound impact that defines the life and death of every star in the universe. We are the future grit in the atmosphere of a phantom that was once a sun. This phantom of a sun, though it has long ceased its nuclear heartbeats, remains a steadfast guardian against the total collapse that gravity so desperately craves. In a living star, the inward pull of mass is balanced by the outward roar of thermal pressure generated by constant atomic fusion. But once the fires go out, the heat that once supported the stellar structure begins to bleed away into the vast, indifferent void. Most matter would simply crumble under such weight, surrendering its volume to the crushing darkness until nothing was left but a point of infinite density. This state of total surrender is the natural inclination of any massive object that can no longer generate the kinetic energy required to push back. Without a constant source of internal heat, the star would inevitably succumb to its own overwhelming mass and vanish from the visible universe. Surprisingly, the white dwarf avoids this fate entirely by stepping away from the laws of thermodynamics and embracing the bizarre, unyielding rules of quantum mechanics. It no longer relies on the random motion of hot gas to hold its shape, but instead turns to the fundamental nature of subatomic particles to maintain its planetary dimensions. This transition marks the birth of a world supported not by the flickering of fire, but by the sheer, stubborn refusal of matter to be compressed further. The resulting object is a masterpiece of stability, held together by forces that do not require a single spark of energy to remain active. It is a quiet, motionless victory over the most powerful force in the universe, a silent defiance of the gravity that tries to pull it into oblivion. This foundational shift ensures that the star can endure for trillions of years as a stable, cooling relic in the deep dark. Deep within the heart of this crystalline relic, the electrons that once swirled freely now follow the strict antisocial dictates of the Pauli exclusion principle. This fundamental law of the subatomic realm states that no two electrons can ever occupy the exact same quantum energy state at the same time. You can think of it as a cosmic law of personal space that prevents these tiny particles from overlapping or sharing the same energetic address. This inherent stubbornness of the electron becomes the primary structural support for the entire mass of the dead star. It is a rigid, microscopic gridlock that defines the physical boundaries of a world roughly the size of a planet. By refusing to occupy the same state, the electrons create a physical barrier that prevents gravity from crushing the star any further. The exclusion principle acts as a permanent, unbreakable rule of existence, ensuring that matter retains its volume even in the absence of heat. It is a testament to the fact that the universe is governed by laws that are far more fundamental than the simple burning of fuel. This microscopic order is what allows the macroscopic star to survive its own death and remain a solid anchor in the void. As the immense weight of the stellar remnant continues to push inward, the electrons are physically forced down into the lowest possible energy states until every single available slot is completely filled. Gravity acts like a relentless hand trying to squeeze a sponge into a thimble, but the sponge is made of particles that refuse to overlap. The electrons fill the bottom energy levels first, creating a solid foundation of occupied states that piles up higher and higher. This filling happens until the Fermi level is reached, a point where every low energy state is taken and the particles have nowhere left to go but up. This process creates a state of total occupancy, a subatomic traffic jam where no particle can move without another one moving out of the way. Because there are no more open seats in the lower energy levels, the particles are locked in place, unable to settle further toward the centre. This creates a vertical wall of occupied states that resists any further compression from the outside. It is a perfect motionless density, achieved through the sheer volume of particles occupying every possible quantum niche. The star becomes a solid, unyielding structure composed of layers of occupied states that refuse to budge under the weight of the galaxy. The electrons are packed so tightly that they no longer behave as individuals, but as a single, collective force that defines the star's interior. This collective state is a unique phase of matter that can only exist in the extreme conditions of a dead star. It is a realm where the density is so great that the normal laws of chemistry are completely overridden by the laws of physics. This absolute occupancy creates a bizarre state known as electron degeneracy pressure, which acts as an invisible and impenetrable quantum shield holding up the mass of the star. It is a pressure that has nothing to do with heat or temperature, but is derived entirely from the speed and stubbornness of the particles themselves. When gravity tries to push the star into a smaller volume, it essentially tries to force the electrons into energy states that are already taken. The electrons respond by pushing back with a force that is billions of times stronger than any chemical bond found in a diamond. This pressure is so immense that it can support the weight of an entire sun concentrated into a sphere the size of our home world. It is the final line of defense for a star, a quantum barricade that refuses to buckle under the weight of trillions of tons. This invisible shield is what allows the white dwarf to survive for eons without any source of internal fuel. It is the ultimate manifestation of the small controlling the large, a microscopic force dictating the survival of a macroscopic giant. This shield remains in place as long as the star exists, providing a permanent and reliable foundation for the dead core. Without this degeneracy pressure, the universe would be filled with many more black holes and infinitely dense points of matter. Instead, the exclusion principle provides a middle ground, a way for stars to find a stable and enduring state of rest. It is a beautiful and effective solution to the problem of stellar death, created by the very nature of matter itself. Surprisingly, the universe allows this degenerate matter to behave in ways that completely contradict our common experience with gases and solids. In a normal gas, adding heat makes the particles move faster and push outward, while cooling them makes the volume contract as the particles lose their kinetic energy. Degenerate matter, however, is almost entirely independent of temperature. It does not expand when heated, nor does it contract as it loses its residual warmth. Because the pressure is created by the quantum occupancy of the states, and not by thermal collisions, the star stays the same size regardless of its internal temperature. This makes the white dwarf an incredibly stable and predictable object, immune to the thermal fluctuations that cause other stars to pulsate. Even as the star cools from brilliant white to a dull infrared glow, its physical dimensions remain locked in place. As you rest here, feel the solid, unchanging weight of your body against the surface below you, noting how you remain perfectly still and supported. You're a stable island of calm in a shifting world, breathing slowly and deeply while your muscles release every last bit of their remaining tension. Just like the steady, unchanging volume of the star, you're anchored in a moment of absolute peace and reliable stillness. This thermal independence is what allows the white dwarf to act as a cosmic clock, cooling at a steady and measurable rate over billions of years. It is a reliable and unchanging object in an evolving universe, providing a constant reference point for the passage of time. The star simply exists, its physical form protected from the changes that affect more volatile and active bodies. If we were to look closer at the relationship between mass and volume in these systems, we would find a counterintuitive reality, where adding more mass actually makes a white dwarf shrink in size. In a normal world, if you add more material to a pile, the pile gets bigger, but in the realm of degenerate matter, the rules are inverted by the power of gravity. When you add mass, the increased gravitational pull squeezes the star even tighter, forcing the internal electrons into even higher energy states. To provide the necessary pressure to counter this extra weight, the electrons must zip around even faster, which they can only do if they are packed into an even smaller volume. This creates a fascinating paradox where a heavyweight star is physically smaller and more compact than its lighter counterparts. The more material the star hoards, the more it is forced to condense its being into a tiny, hyperdense sphere. It is a journey of refinement where greatness leads to a smaller, more concentrated footprint in the dark. This inverse relationship continues until the star reaches the absolute limit of its stability, becoming a more and more perfect sphere of compressed matter. The star literally becomes more of itself while taking up less space in the galaxy, a concentrated point of power and density. This shrinking process is a direct result of the balance between the outward quantum pressure and the inward pull of mass. It reveals a hidden order in the cosmos, where the physical size of an object is a direct reflection of its internal struggles. The star becomes a more intense version of its former self, trading its volume for a higher degree of physical presence. This structure leads to a striking physical reality, where a white dwarf that is twice as massive as another will be physically and significantly smaller in its overall diameter. While a light white dwarf might be the size of the Earth, one approaching the absolute mass limit would be squeezed down to the size of a small moon. This inverse relationship between weight and size is one of the most defining characteristics of the degenerate state, making these stars some of the most compact objects in the sky. The denser the star becomes, the more the rules of quantum mechanics dominate its physical appearance, overriding the common sense geometry we see in the larger universe. It is as if the star is trying to disappear into itself, pulling its boundaries inward as it gathers more and more of the universe's weight. This extreme compactness is what gives the white dwarf its intense surface gravity and its ability to warp the light around it. The remnant stands as a small but mighty remnant, hiding the mass of a sun inside a package that seems impossibly petite to our eyes. This compact nature ensures that the star remains a potent gravitational force, even when it is too dim to be seen with the naked eye. The physical size of the star becomes a direct measure of the intense struggle between gravity and quantum pressure that defines its life. Within this tiny sphere, the matter is packed so tightly that a single handful would weigh more than a fleet of ocean liners. It is a level of compression that challenges our understanding of what matter is capable of enduring. The star is a masterpiece of compact design, a world where the laws of physics are pushed to their ultimate and most extreme limits. To maintain this delicate balance and prevent the star from collapsing under its own weight, the trapped electrons zip around internally at speeds approaching the speed of light. This high-speed movement is known as Fermi velocity, and it is a direct consequence of the particles being forced into high-energy states by the surrounding pressure. Even though the star might be cooling and the surface might feel cold in a cosmic sense, the interior is a frantic, high-speed racetrack. These electrons are moving so fast that they gain relativistic mass, which increases the pressure they exert against the inward pull of gravity. Without this near-light speed movement, the star would have no way to generate the necessary outward force to remain stable. The kinetic energy of the electrons becomes the star's new form of support, replacing the thermal heat of its former life as a living sun. Allow your mind to drift on the image of these fast-moving particles, while your own body remains in a state of deep, effortless quiet. You're the motionless center of this frantic cosmic activity, perfectly safe and entirely at rest while the universe works at incredible speeds far beyond your perception. Your heart beats with a slow, steady rhythm that anchors you to this moment of total and absolute relaxation. The incredible speed of these electrons is what gives the star its unyielding structural integrity. They create a wall of kinetic force that is impenetrable to any external influence, protecting the star's core from any further collapse. This high-speed environment is a world where time and space are warped by the sheer velocity of the particles themselves. It is a profound paradox that the macroscopic shape and survival of a massive dead star are maintained entirely by microscopic quantum rules that govern the smallest particles in existence. We often think of the universe as being divided into the very large and the very small, with completely different laws for each. Yet, in the white dwarf, these two worlds are perfectly integrated, with the radius of a planet-sized object determined by the Planck constant. The star is essentially a macroscopic quantum object, a world whose very existence is a bridge between the subatomic and the celestial. Every mile of its diameter is a direct reflection of the wave functions of its constituent electrons, making it a visible laboratory for the most fundamental laws of nature. It is a stunning realization that the grand architecture of the sky is built upon the silent, invisible stubbornness of particles we can never see. This object proves that the smallest details of reality are often the ones that hold the entire structure together. It is a testament to the interconnectedness of all things, where the behavior of a single electron can dictate the fate of a massive stellar core. The star remains a silent witness to the power of quantum mechanics, standing as a physical proof of the universe's most hidden laws. The geometry of the star is a map of the quantum world, translated into a physical form that we can observe from across the galaxy. It is a beautiful and elegant expression of the unity of the laws of physics, showing that the same rules apply to atoms and stars alike. The white dwarf is the ultimate manifestation of the power of the small to control the large. Understanding this truly strange state of matter perfectly bridges the conceptual gap between the vast scales of astrophysics and the intricate world of subatomic particle physics. It shows us that to understand the death of a sun, we must first understand the behavior of the particles that make up its core. This fusion of scientific disciplines has allowed us to predict the existence of even more exotic objects, like neutron stars and black holes. The white dwarf serves as our first introduction to the degenerate universe, a realm where gravity and quantum mechanics are the only two forces that matter. By studying these cooling remnants, we're essentially peering into the foundations of reality itself, seeing how the universe balances its energy and its mass. This knowledge turns the fading light of a dead star into a brilliant tool for discovery, revealing the hidden connections that bind the smallest atom to the largest galaxy. This scientific bridge is a testament to human curiosity and our ability to decipher the most complex secrets of the sky. It reminds us that every light in the night is a source of knowledge, waiting for us to understand the rules that make it shine. The white dwarf is not just a dead star, but a brilliant teacher that continues to illuminate the path of scientific discovery. The path of scientific discovery leads us to a quiet, ultimate realization. The white dwarf possesses absolutely no internal source of nuclear fuel to sustain its brilliance. Unlike the active suns that define the current age of the galaxy, this remnant is no longer an engine of production, but a storage vessel for ancient energy. Its long and remarkably patient life is defined entirely as a slow, unstoppable process of cooling, a gradual surrender of heat to the vast and hungry vacuum. This cooling is not a failure of physics, but a natural and graceful transition toward the ultimate equilibrium of the universe. Without the chaotic churning of fusion to replenish its warmth, the star becomes a perfect study in thermodynamics on a cosmic scale. It acts as a closed system, slowly venting the thermal legacy of its former life through its thin, heavy atmosphere into the deep dark. Every photon that escapes the surface is a fragment of the star's past, leaving the core slightly colder and more settled than it was a moment before. This process is so incredibly efficient and slow that the star remains visible for spans of time that dwarf the entire history of life on our planet. It is a masterpiece of thermal endurance, a glowing ember that refuses to go out until the very laws of the universe demand its final silence. The star remains a beacon of the past, stubbornly holding onto its warmth while the galaxies themselves undergo their slow and inevitable evolution. It is the final closing of the energetic accounts, a total and complete distribution of the star's ancient thermal wealth. We are witnessing the quiet, final moments of a star that has given everything it has to the universe. Surprisingly, the universe itself is not yet old enough for even a single white dwarf to have completely cooled down to the background temperature of deep space, despite the billions of years that have passed since the first generations of stars perished. The sheer density and thermal mass of these remnants act as an incredible reservoir for heat. We currently live in a young and vibrant cosmos, where every white dwarf ever created is still stubbornly warm, still radiating its presence into the void. This thermal persistence means that the coldest remnants currently known are still far hotter than the freezing vacuum of the interstellar medium. We are witnessing the first acts of a very long play, where the stage is still illuminated by the persistent warmth of those that have already left the spotlight. Every white dwarf in the sky is a survivor of a previous era, carrying its heat into a future that has not yet arrived. It is a profound testament to the stability of stellar matter and the vastness of the cosmic timeline that governs us all. Trillions of years from now, long after the last living sun has sputtered into darkness, the very last vestige of the white dwarf's residual heat will finally bleed out into the continually expanding cosmos. This era, often called the Degenerate Age, will see the universe populated by these fading pearls as they slowly merge with the background temperature of space. The cooling process continues with a geometric patience, a final and absolute dissipation of the energy that once defined the vibrant spiral arms of the galaxy. As the expansion of the universe carries the galaxies further apart, these stars will drift as isolated points of warmth in an increasingly hollow and cold expanse. The light they emit will shift further into the infrared and microwave spectra, becoming a whisper so faint that it is virtually indistinguishable from the cosmic background radiation. It is the final closing of the energetic accounts, a total and complete distribution of the star's ancient thermal wealth. The star simply exists, its physical form protected from the changes that affect more volatile and active bodies by its own unyielding density. Notice how your own body naturally seeks a comfortable, steady temperature, balancing your internal warmth against the cool air of your room. Your breath carries away a tiny fragment of your own energy with every exhale, a soft and rhythmic exchange that keeps you in perfect harmony with your surroundings. Allow yourself to settle into this effortless balance, feeling completely at peace as you mimic the star's own slow and graceful release of the day's heat. This structure will ultimately and inevitably transform into a theoretical black dwarf, a dense and frozen object emitting absolutely no detectable light or heat whatsoever. This is the final, unseen stage of stellar evolution, a state of matter so cold that it has reached total thermal equilibrium with the absolute zero of the void. Because the cooling process takes longer than the current age of the universe, no black dwarf yet exists, making them the ghosts of a future we can only predict through the rigorous laws of physics. It represents the absolute end of the star's journey, a transition from a glowing phantom into a silent and invisible monument of mass. The black dwarf remains a sphere of degenerate matter, its internal structure still held up by quantum pressure, but its surface is now as dark as the space that surrounds it. It is the ultimate expression of cosmic stillness, a world where all thermal motion has finally and permanently ceased. A black dwarf is a perfect absorber and a non-emitter, a dark mirror reflecting the final cold state of an old universe. It is a silent sentinel drifting through a galaxy that has long since run out of fuel to make new stars. The transformation is absolute, marking the moment when the star finally vanishes from the electromagnetic record and enters the realm of eternal shadow. It is a state of existence that defies our standard definitions of a star, existing as a solid and frozen relic in a universe of darkness. The white dwarf has finally found its ultimate resting place, becoming a permanent and unmoving part of the cosmic landscape. These frozen spheres will drift completely invisibly through an increasingly darkening universe, their crystalline diamond structures forever locked in the grip of absolute zero. Even though they possess the mass of a sun, they will cast no light and reveal no warmth, becoming the ultimate stealth objects of the deep cosmos. They are cold, solid, and incredibly dense, their internal lattices of carbon and oxygen frozen into a state of permanent and unyielding rigidity. If we were to look closer, we would see a world where the very concept of molecular motion has been almost entirely extinguished. The diamond core we explored earlier is now a frozen heart, its atoms held in place by a chill so profound that it borders on the physical limit of the universe. These spheres are the ultimate survivors, their dense bodies protected by the vacuum from any further change or decay. If a rogue planet were to pass by, it would find no light to see its way, and no warmth to thaw its frozen crust. The black dwarf is a silent companion in the dark, a massive and invisible presence that remains unchanged while the rest of the universe fades away. It is a profound state of permanence, a crystalline legacy that exists outside the reach of time's thermal arrows. The star has become an eternal diamond, a monument to the energy that once roared within its core. It is the ultimate manifestation of the universe's ability to turn the remnants of destruction into something of profound and structured elegance. Deep within the far future, black dwarfs will be practically undetectable to any observer, revealed only indirectly by their immense gravitational influence on passing spatial objects. Because they emit no radiation, they cannot be seen with telescopes or thermal sensors, appearing instead as holes in the starlit sky. They will be found only through the way they warp the paths of stray gas, or the orbits of wandering planets that happen to drift into their local dominion. A beam of light from a distant source might be bent around the invisible sphere through gravitational lensing, creating a ghostly distortion in the void. This invisible tug is the only way these remnants will interact with the rest of the cosmos, acting as hidden anchors of mass in a hollow galaxy. They are the ultimate enigmas, objects that possess nearly all the weight of a star but none of its typical celestial characteristics. Their existence is a challenge to our perception, a reminder that the universe contains vast amounts of matter that we can never truly see. They are the silent directors of the cosmic dance, guiding the motions of the dark with their unyielding weight. As you lie in the quiet of your sanctuary, feel the reliable and invisible pull of gravity holding you gently to the earth. It is a constant, reassuring presence that requires no light or sound to let you know it is there, keeping you safely anchored and supported. Let this invisible connection deepen your sense of security, allowing you to trust in the steady and unchanging forces that govern your world. Some theoretical physics models suggest that the mysterious process of proton decay might eventually cause even these incredibly stable objects to evaporate into nothingness. Over spans of time so vast they are written in powers of 10 that defy imagination, the very building blocks of the star's atoms might begin to disintegrate. If the proton is not a truly permanent particle, the crystalline diamond lattice will slowly but surely begin to dissolve from the inside out. The star would not explode or collapse, but would instead fade away atom by atom, turning its massive physical presence into a thin mist of subatomic radiation. This evaporation would be so slow that the star would effectively last for many orders of magnitude longer than the current age of the universe. It is a final, slow-motion disappearing act, where the very matter that was forged in the hearts of suns is returned to the vacuum of space. If this theory is correct, then even the most stable monuments of the degenerate age are ultimately temporary. The universe may eventually reach a state of absolute emptiness, where even the cold, dark embers of the first stars have vanished into the expanding dark. This ultimate evaporation represents the final victory of entropy over the structured matter of the cosmos. It is a sobering thought, but also a beautiful one, suggesting a universe that is constantly and perfectly recycled. The star's final act is to surrender its very substance, returning to the void from which it was once born. It is a final quiet breath of nuclear activity in a universe that has otherwise gone cold and dark. The star remains a slow-burning furnace, using the strange rules of the subatomic world to continue its elemental evolution long after its fire has died. This cold fusion ensures that the star's internal history continues to unfold, even in the absolute silence of the far future. The star acts as a laboratory for the most improbable events in physics, where things that are impossible on human timescales become inevitable over cosmic durations. It is a beautiful and patient transformation, a final refinement of matter into its most stable and energetic configuration. This process ensures that the star's internal legacy is one of constant and quiet change, even when it appears motionless to the outside world. The white dwarf continues to evolve, proving that the universe is never truly finished with its creations. It is actively theorized that black dwarfs might eventually collapse entirely into iron spheres, representing the absolute final energetic state of all stellar matter. Iron is the most stable element in the universe, the point where nuclear fusion and fission can no longer release any energy. By turning entirely into iron through the patient work of quantum tunneling, the star reaches its ultimate thermodynamic destination. This iron remnant would be the most concentrated and permanent form of matter possible, a solid ball of metal holding the mass of a sun. This iron star is the end of the chemical road, a state where no further change can occur through the standard forces of nature. The star has effectively reached the bottom of the cosmic energy well, becoming a perfect and unchanging relic of the starlit era. Surprising as it may seem, these iron stars may be the last structured objects in the entire universe. They would drift as cold, metallic ghosts in an empty and expanding void, the final survivors of the grand project of stellar evolution. They will stand forever as silent and invisible monuments to the radiant stars that once vibrantly illuminated the cosmic dark. Every black dwarf is a testament to a journey that began with the collapse of a gas cloud and ended with a frozen sphere of iron and diamond. They hold within them the entire history of the galaxy, the memories of planetary systems destroyed, and the record of the nuclear fires that forged the heavy elements of the universe. While the rest of the universe may fade into a featureless sea of radiation, these remnants remain as solid evidence that starlight once existed. The journey of the star is complete, and the universe has finally found its rest in the enduring silence of the void. These silent monuments represent the ultimate triumph of order over chaos, a lasting legacy that remains long after the last photon has been extinguished. They are the final and absolute testament to the beauty and persistence of the natural world. The white dwarf stands as the ultimate cosmic paradox, an impossibly dense quantum crystal forged from stellar death that continues to illuminate the expansion of space long after its original fires have gone out. It is a bridge between the subatomic world and the grand architecture of the galaxy, a teacher that reveals the hidden laws of reality through its very existence. From its birth in a spectacular nebula to its final state as an invisible iron sphere, it remains one of the most profound and beautiful objects in the known universe. This final realization ties together the entire journey, showing that even in death, a star can provide the light and knowledge needed to understand the vast and mysterious cosmos. If we were to look closer at the entire journey, we find that the white dwarf stands as the ultimate cosmic paradox. This impossibly dense quantum crystal is forged from the very heart of stellar death, yet it continues to illuminate the expansion of space long after its original fires have gone out. It is the final and absolute testament to the beauty and persistence of the natural world. This quiet room is now your own private observatory, a place where the heavy lessons of the stars can finally settle into the stillness of your rest. Notice your toes first. letting them go completely limp as if they were drifting in the weightless dark between galaxies. The soles of your feet and your heels are releasing all their tension, sinking deep into the mattress like a cooling remnant finding its final place in the cosmic grid. Surprisingly, the body knows exactly how to surrender its weight once the mind has travelled through such vast distances. Your ankles and calves are becoming heavy and warm, shedding the day's movement just as a star sheds its outer layers to reveal the calm core beneath. Every muscle in your thighs and hips is relaxing now, perfectly supported by the gravity of your own home. If we were to look closer at your breathing, we would see a slow, rhythmic tide that mirrors the patient cooling of a distant diamond heart. Your lower back and stomach are soft and quiet, rising and falling with an effortless grace that requires no thought or direction. The peace of the deep void is now the peace of your own physical form, anchored and entirely safe. The softness of the sheets against your skin provides a gentle boundary, a cocoon of absolute comfort and security. Your fingers are curling naturally, releasing any remaining grip on the thoughts or tasks of the day. Every joint in your hands and wrists feels loose and light, resting in the warmth of the blankets. This mattress is a vast and reliable foundation, holding you up with a steady strength that allows you to sink even deeper. Your shoulders are dropping away from your ears, melting into the pillow as the last bit of tightness vanishes from your neck. The muscles in your jaw are relaxing, and your tongue is resting lightly behind your teeth. Notice how the air in the room is cool and still, a silent companion to your own deep and restorative breaths. Your eyelids are heavy, smoothed out by the weight of a peaceful and dreamless sleep. Every line on your forehead is disappearing, replaced by a surface of absolute and unblemished calm. The darkness is a warm and inviting ocean, wrapping around you and pulling you gently toward the center of your own peace. You are floating in a state of pure and effortless existence, where the only sound is the quiet echo of your own breath. Every part of you is now asleep, drifting into the soft and silent depths of the night. And now, 101 wonders are resting with you. Sleep now. Good night.